Right. Okay. So let's see. So yesterday we looked at how we can improve the structure, readability, and modifiability of our code. So it's much easier to test its functionality, improve it further, easier to change, fix bugs, and so on. So today we're going to look at another type of correctness, that whether our code behaves correctly and how we can determine whether that is in fact the case. So as we continue to make changes to our code, we need to ensure our software continues to operate as we would expect. So in some sense, we make sure it behaves correctly, depending on what we define as correct behavior. As code increases in size and complexity, correctness becomes increasingly difficult to reason about since our code becomes more difficult to reason about. So the goal of software testing is to check that the actual results produced by a piece of code meet some specific expectations, that they're working correctly. So the questions really then become, how can we verify our code is correct? How can we automate our software tests? What makes a good test? What parts of our code should we prioritize for testing? And also another thing we'll be looking at is how we can take our automation one step further with something known as continuous integration. So this enables us to automate running our tests in the background, and indeed pretty much running anything we want in the background as changes are made to our code in our GitHub revision control repository. And this kind of facility allows us to check for errors as our code changes and evolves in the background, and that's something else we'll be covering today. Right, so I just need to sort this. There we go. So what if we make a mistake in our code? Can I have a show of green ticks if you've ever made an error in your code? I'm going to put my hand firmly up here. So, you've been coding and you make a mistake, and yeah, it's going to happen. And you will continue to make mistakes in your code. There should be no misunderstanding about it. Humans make mistakes. Our software will contain defects, which may occur when collecting requirements for building our software, designing it, or writing the code itself. So it's not just about whether we write the code correctly, it's about whether we're doing all the preparatory steps correctly as well. And there's a very interesting, well-documented cost of fixing bugs that increases as we go through this development process. So if it costs an hour to fix a bug in a software's design, if you don't fix it, it may cost 10 hours to fix it during development. And if you have a piece of code that's out there in the wild, perhaps functioning as a service and being used by others, it could be as high as 100 or maybe even 150 hours, some estimate, to fix in production. Okay, so it becomes more costly as we go through the process of developing and using our code to fix mistakes later on. Things get more complex, the way it's being used, it gets potentially more complex. So we want to try and fix errors as early as possible. And prevention, therefore, is better and generally a lot more cheaper than failure and fixing it later. So yeah, the other point here is get your requirements and design right before you start coding. Understand what it is that needs to be built, understand how you're going to build it and what the shape of that will look like. So I think Alice gave some brief examples in her course introduction of example projects that went wrong. I'd like to zoom in on a little detail, one of them, which is particularly interesting. So this is the example of the Knight Capital Automated Stock Trading System, which had a catastrophic occurrence. So the system was new but contained a flaw, the kind of flaw that probably keeps stockbrokers up at night. The New York Stock Exchange opened on August the 1st, 2012, and for some reason, this shiny and newly commissioned stock trading system decided to go on a shopping spree. It snapped up 150 stocks at a cost of $7 billion, all within the first hour of trading. When all was said and done, it cost them $440 million. So how did that happen? Knight's software development team was making changes to the new system rapidly up until the deadline to go live. And unfortunately, the changes activated some old code features which still remained. And once orders from broker dealers started coming in, the old code sitting on one improperly updated server was activated, and the server began to continuously send thousands of stock purchase orders under the wrong conditions. And the results were truly catastrophic, leading to this humongous loss. Knight admitted many of their systems were not properly tested and it could have been caught. Now, this is a very extreme example, of course, but it shows you the extent to which testing is important to capture these kinds of errors. And hopefully that's not something that will ever happen to you, but testing is one of those things we can do to make sure it doesn't happen. So testing code helps us identify problems, but the benefits actually go even further than that. So it helps us to be more productive, as it helps us to identify and fix problems with our code early. It allows us to make changes, run tests, identify problems. It might seem counterintuitive since you need to put in the effort to do it and write tests and learn how to do that. But I've worked on many software development projects in the past, and in the long term, testing does save you considerable time. In particular, automated testing is something that takes so little time to run in contrast to actual development. It's really a no-brainer. Once you set it up, those tests are there. You can just run these automated tests, check your code is working as you continuously evolve your code. And of course, that ensures that actually is dependent on you having well-considered tests in the first place. And over time, it's something you can fold into your day-to-day practices of coding and can become second nature. It also allows us to demonstrate to ourselves and others that our code does what we claim. Okay, so more importantly, if we share our test alongside our code, it allows others to verify our software for themselves. And building on something that I think Philly mentioned yesterday, the act of writing tests encourages us to structure our code with better modularity, since testing of code requires well-structured code in order to test each logical piece of it. With monolithic code, that becomes incredibly difficult. If you have just one huge monolithic script, very difficult to test each of the different pathways through the code, check that each one is working correctly. Whereas if you have logical modular code snippets as functions, for example, or classes, you can test these individually and check their correctness, which is much, much easier to reason about and do. And often this results in a more readable, modular, and maintainable code base, so it's easier to extend or repurpose or reuse in the future. The other thing is by demonstrating our code works as expected and produces accurate results, it gives us confidence to share our code with others as well. And it also helps to bring peace of mind by providing a step-by-step methodical approach we can apply to verify our code is correct by some measure. Another way to look at this is from the perspective of fair software. So, as a reminder, fair software stands for findable, accessible, interoperable, and reusable. So, in particular, software testing improves the accessibility and reusability of our code. So, in particular, automated tests act as examples for how to utilize functions in our code, lifting the lid on how the internals of our code works. So, anyone who wants to reuse our code can understand technically how it works. In addition to reading documentation, which Aman is going to cover tomorrow, it also means anyone else can rerun tests if they want to change or extend the code to ensure it continues to work. So as well as it giving us benefit in our development process, it helps others who wish to extend and develop our code as well. And this increases the confidence of others. They can also safely amend the code. Also, manually testing our software also can highlight issues with design and usability, which can present barriers to accessibility of our code as well. So let's look at this from another two perspectives: reusing someone else's code, adapting it for our own purposes, and making our software available to others to reuse, including a future version of ourselves, which may now remember the intricacies, may not now remember the intricacies of how it all works. So is anyone here, if I could have a show of hands, for anyone who's come back to code, perhaps a bit later, that they themselves have written and, kind of went, I wonder how that works? Perhaps a bit confusing. I've done this on numerous occasions. I still occasionally do it today. It happens. It's going to happen. And one of those things that can be really useful is if we're writing tests, these tests can actually give us an idea, not just of correctness, but also of how we're using the code to call it to do various things as well. So that can really be helpful for us to understand that. And it also means as we continue to make changes to our code, which we may not fully understand, these tests can reinforce whether the code is correct. So yes, it can be helpful to think of these code tests as both a safety net and a kind of alarm system. It's a safety net to reassure us our code is working as expected now, before we change anything or as we change things, but also an alarm system. As we experiment with changes to code, we rerun our tests fail, tell us changes have broken something, we need to find a solution, or perhaps even go back to the drawing board. Perhaps what we're pursuing as a method isn't going to work in our code, and it can help tell us that. However, this assumes the tests we have provided and developed are sensible, appropriately cover and test the path through our code. So conversely, it kind of means we should provide tests in our own code that sufficiently test that code. Okay. So there's a few types of software tests that we can use, and we're going to be looking into particularly one of these types of code, which is unit tests, and that's the first one that's on this slide. So with unit tests, these focus on testing individual functions or classes in isolation. They ensure that each small part of the software performs as intended. Okay, this is the lowest level of automated testing. At the next level, we have integration tests, and these verify that multiple parts of the code, such as functions and modules, work together correctly. Okay, and then at an even bigger level, we have the entire system, the whole program being tested in an end-to-end test. And this checks that the program as a whole is behaving as expected all the way from user input all the way to eventual output through the system. Okay, and there's also another type of testing, a special type of testing called regression testing. And this is where we're rerunning existing tests to ensure behavior is still correct. Okay, and as bugs are introduced into our system, what we can do is after we fix them is create a test just to check that that bug is not coming back. It is, so our code is not regressing backwards. And so this can be a good practice for us to ensure that as code changes and bugs are introduced, we can run these checks to make sure these bugs are not reintroducing themselves. So testing is a key activity. Often a key problem at any organization, including an industry, is the prioritization on non-development activities that benefit business goals, right? In our case, research goals. Sometimes things like testing our software get neglected in favor of greater features or functionality. Okay, so even though testing is critical, sometimes that is seen as something that's not perhaps as important as, getting some more results to put in our papers or so on. And of course, those research goals, with PI saying you need to get the paper out or whatever, our supervisors or our project managers or whatever saying you need to get this output out, it means that some things can be sacrificed, and testing can be one of those. When we do find the time, one way to do it is to test things manually, right? Checking our software works as expected given a range of inputs. And, we can take this further into a more organized way, a more formal way. So we write down in what is typically called a test plan about what the test should be as test cases. Okay. And this is a way of organizing how we do this manual testing. So for a test case, we state what we are testing, what the inputs are, and what the expected result will be. And we run these tests after we make changes and also prior to release or certainly publishing results. And as our software changes, we revise this list of tests, and so they remain relevant to the software as the software evolves. So this is very important, and manual testing in some form is always necessary. It does have disadvantages. It's a manual process, and of course, people are prone to error, people are fallible, mistakes are going to be made. So the worst case, a test is conducted incorrectly. A test passes when the code is actually incorrect. The other thing is that it's a time-consuming process. Doing manual testing for a long period of time of software is particularly boring, and humans are not very good at doing repetitive things over and over and over many times, particularly when the results always are as what you would hope or expect, or at least most of the time. Although when testing finds a critical error, you're going to be glad you did it. Okay, so here's where automation can help us. Computers are fantastic at doing repetitive tasks that are really boring many times and doing them very quickly. So if we can capture test cases as processes we can execute, that's going to save us a lot of time. And so, plus, whenever we make changes to our code, we can just rerun these tests quickly. So what we can do is write snippets of code that actually test specific features or functions in our code and run those. And a key thing is that it can save you effort in the long run. Fixing bugs later takes more effort, as we've said. So automating this testing, running it quickly, can really save us a lot of time by creating what's known as a fail-fast environment. We make changes, we're able to see if something's going to fail very quickly, we're able to resolve these issues more quickly than we would otherwise. Okay. And a very important thing to mention is that automated testing should not completely replace manual testing. Manual testing is expensive, it's still incredibly valuable, and humans can spot certain errors far better than automated testing methods. So with image generation, for example, with plots of results, a very good idea is to check this sort of thing manually. We can use automated testing for things that perhaps are to do with creating the results that go into generating the plots, but doing that in an automated way can be very, very difficult, and humans are very good at spotting errors visually. Okay, so automated testing is something that should complement manual testing. So what we're going to look at in the first portion of this session is we're going to look at informal versus formal testing. We're also going to look at a popular and use a popular Python test framework to write and run unit tests. Okay, we're going to look at how to structure these tests, how to write them, and also how we can create many of these tests within what's known as a test suite, a set of tests that we can run over and over again when we need to. We're also going to look at how we can use test parameterization to reuse unit test code over multiple tests. So it saves us using the same code, copying and pasting the same code all the time. Duplicate code is usually a bad idea. And this is one way to reduce the code footprint that we can reuse that code over again for different tests. And we're also going to see how we can run unit tests within VS Code as well. Right. So before I proceed, what questions do people have? And of course, feel free to ask questions throughout at any time. Feel free to put them in the chat, or you can raise a hand or shout it out. It's entirely up to you. So while I do that, think of any questions. What I'm going to do is I'm just going to switch over my screen. Right. Okay, so I'm not quite sure what's happened there. My window has completely disappeared. Uh, that's rather bizarre. Okay, so I'm not quite sure what's happened, but my main window for this meeting has completely disappeared. I'm going to have to come back out and come back in. My apologies. I'll see you in a moment.
Yes, Steve is coming back.
Okay, apologies for that. I'm not quite sure what happened there. That was a bit scary. Anyway, let's see if we can continue. Right. Okay. So what we're going to do now is we're going to move over to live coding. Okay. So what I'd like you to do is, first of all, to open Visual Studio Code as you had it before, and let's get into the same state that we were in previously yesterday. Okay. So I'm just going to run Visual Studio Code and then I'll share my screen. Okay, so let's see. I'm just going to share this. All right. Okay, is that clearly being displayed? Can people see that? Yeah. Okay. Right. So I'm
Yes, we
just
can see it, but if you make it a little bit bigger. Thanks very much too.
absolutely yes. That's the way to do it. Okay. So what I'm going to do is I'm just going to open a project that I had yesterday. So I'm just going to open my folder. I'm just going to travel to that, and you can do the same. And when you've done that, if you could give me a green tick. That would be great, just so I can know that you're there. I'm having to currently fight a lot of my windows when sharing screens. It's going to take me a little while, so apologies for that. Right, there we go. Okay, so does that look okay, or should we have the text a bit bigger? It's entirely up to you. If you'd like to see the text bigger, feel free to mention in the chat. Yeah, just Steve, can you increase the size of that? That will not be a problem. That's too small. Appreciate some people are on laptops with smaller screens. Right, hey, let's make that a bit bigger. All right, okay, how's that? Does that look okay? Awesome. Okay, right. So what we're going to do now is we're going to look at informal testing. Okay. So how should we test our code? So one approach we could do is to copy paste a code or function into a Python terminal. Okay, so for example, if I were to run a terminal in here, what I could do is I could do new terminal, right? And then what I could do is um, I can act. What the next thing I should do, of course, and I should mention this, is we need to reactivate our our virtual environment. So if you're on Linux or Mac, it looks a bit like this. Okay, source VM spacewalk slash bin slash activate. If you're on Windows, it's going to look a little different. It's going to be something like source VM spacewalks scripts with a capital S activate. Okay, so once you've all managed to make sure that your environment has been activated, just give me a green tick, and then we'll move on. Okay, all right. Okay, looks like people are almost there. All right, right, my windows again. Right, okay, so I think we're just about there. If you're having any issues, of course, please feel free to ask questions in the chat or to shout out. Okay, so what we could do is we could just use our Python interpreter, and the way we can use that is by typing in Python, Python 3, pressing return, and this puts us into the Python interpreter. Okay. And this means that we could copy our code in here and we could use it that way. And we can call our functions and just check that things are working okay. All right. But here's the thing with the Python interpreter. The way this is a different interpreter to the terminal that we saw earlier yesterday in Bash. So this allows us to type only Python commands, not Bash commands. Okay, just to clarify. This can often be a tripping up point for some people who, think that it's possible to run bash commands in the terminal within Python, which of course you can't. And so this is a very different sort of interface just to Python alone. But once you run this, a helpful thing to know how to do is how to escape it, to get out of it. And we can do that by doing exit, open and close brackets. That enables us to get out of the terminal. So give that a bit of a practice now. Just make sure you can do that so we don't get stuck later. So yeah, you can just type Python, Python 3, and then just do exit, open and close. Okay. And that's one way we could do this. So let's do it for our text duration function. So you may recall that our text duration function looks a bit like this. Okay, so this converts a spacewalk duration stored as a string in the format something like HH, hours, and minutes, so 1210 or something like that, into a decimal hours. So if it were something like, I don't know, 115, then that's 1 hour and 15 minutes. It should return a numerical decimal value of 1.25. Okay. So what we can do is start our Python terminal, right? And what we could do is we could do this. We could then use the Python terminal, as we would in the Python script, to import a function from EDA data analysis. And we're going to import that text to duration function. Okay. Right. So when you've got to that point, if you could give me a green tick, that would be great. I'm just going to clear the feedback. If you're having any issues, of course, please let us know. Put it into the chat, or shout out, or put your hand up. Right. So I can see that a few of you have done it. I'm guessing you probably need a bit more time. So I'll just give you a bit more time to type that in. I know that, I know what I'm typing, you don't know what I'm typing. So, right. I see someone has encountered an issue. So feel free to type that into the chat, or let us know what's going on. Oh, no, it's disappeared. I don't know if that issue has been resolved. I hope it has. Right. Okay. So again, if you're having issues, let us know. Right. So what we can do now is we can test by just calling that function, right? So we could do text to, oh, yes, go on.
Sorry, 1 second. I'm getting an error that just says no
Mm.
module named EVA data analysis.py.
Ah, right. Okay. Interesting. So just a couple of checks then. I'm just going to just do this. I just want to check that you're in your Spacewalks directory. Are you currently in your Spacewalks directory? Is that
Yeah,
correct?
so that's where I initiated the Python interpreter.
Okay. If you type ls and press return, do you see EVA data analysis there? Just want to double check. EVA data analysis.py.
Right, sorry. So should I type ls into the Python interpreter or exit and then
Good question. If you exit the Python interpreter for now, and
yes.
then type,
Okay.
yeah, so you can do exit,
Yeah,
open close
so it's
bracket.
there.
Ah, good. Okay, so that's the first step. So let's just go back into the Python interpreter, right? And this is just for anyone else who might also be experiencing this issue, because it could easily be a typo or something. I make these all the time. What we can do is we can do from EVA underscore data underscore analysis, then space import space text underscore to underscore
Oh.
duration.
Sorry, so do I not say from EVA data analysis.py?
Ah, yes, this is a good one. This is well worth being clear about. So yeah, we don't need to do that. So it's assuming that when you do from EVA data analysis, for example, that it's a Python file. So the good thing is we don't even need to say .py there, right? So
Ah, okay.
hopefully that should resolve your issue. Fingers crossed.
All right. Yeah, that's all good. Thank you.
Brilliant. Okay, excellent stuff. Right. Okay, so what we can do now is we can test this by running our function, right? Just directly by doing text to duration, open brackets 10 o'clock, for example, and pressing return. Okay, and this is a very simple way for us to test our code. That looks right. Okay, that looks right. That's the time is a decimal 10.0 looks fine. Okay, and we could also do it again. So whilst we're within the Python interpreter, a nice quick way of accessing what we've already typed, like we can on the bash command line, is press the up arrow. And that gives us what we've typed in before, which is kind of handy if you want to change it. So let's just do that, press the up arrow, and then move and change that 10 to a 0. Okay, so now we've got basically text to duration midnight. Okay, and if we press return, that's 0.0. So that all seems correct so far. If you've been able to do that, if you give us a green tick, that'd be great. So I'm going to be asking you to do this a little bit frequently at the start, so my apologies for that. It's just to make sure we're on an even keel before we proceed. Okay. Okay, so if you've all been able to get to that state, feel free to give us a green tick. Again, got any problems, let us know. Right. Okay. Excellent stuff. So testing code in this informal way is an important process to go through as we draft our code for the first time. And as we're doing this, this is part of our development process, right? We write some code, ideally in nice modular functions. We test those functions to make sure they're correct before we integrate them into our wider code base. Because when we do that, it can be a little difficult to reason about what's correct. If we've got lots of new functions, we just bundled them all in at one time, and hopefully everything works. But if we do this in a kind of stepwise fashion, make a function, test it, it's a good approach to take. Another tool that can help us here is something called the Jupyter Notebook. So if you've ever heard of the Jupyter Notebook, feel free to give us a green tick. If you haven't heard of it, give us a red cross. That's absolutely fine. It's one of those things that not everybody comes into contact with. Looks like most people have. Okay, so here's a link in the chat for anyone who wants to check out that. So like the Python terminal, the Jupyter Notebook is an interactive environment for writing and running code, but it works within your browser. It's a GUI tool, perhaps, which supports all kinds of interactive outputs, including many interactive visualization libraries. Um, and that also is great if you want to do sort of stepwise testing, because, well, basically Jupyter Notebooks is an interesting way of developing code. You basically write code snippets into cells, and you can execute any one of those cells at any time, which is really handy and flexible for testing and exploring code. So that could be a really good way to exploring code, exploring how to write code as well. So if that's of any interest, feel free to have a look at that. However, using an interpreter to do it this way, or something like the Jupyter Notebook like that, just to do testing is kind of limited. It does have some serious drawbacks to this approach if we use it as our only form of testing. So we're going to do a challenge now. I'm just going to, oh, wow, I've got two massive screens and I am still running out of space. So what we can do is we can do the first exercise. I'm just going to copy this into the chat. So what I'd like is for you to think about these two questions. So we'd like you to share your answers to these in the chat, sorry, not in the chat, in the code, code.env shared doc. Okay, so first of these is why might we choose to test our code informally? Have a think, why is that useful? And then the second question is, what are the limitations of relying solely on doing this to verify a piece of code is behaving as expected? So it's not a test. You can feel free to say whatever you like. Yeah, see what you say. So I'll give you a couple of minutes to have a think and write down some ideas there. Could be, of course, that in the intro that I've mentioned some of the answers already, but it's good to just to cast our mind back and reinforce what we've already learned. That's interesting. So someone's mentioned you'll miss black swan problems. Would someone like to elucidate what that particular phrase means? I've not heard that one before.
So this is something that one of my friends that works in consulting talked about. It's basically the problems that you don't even think you might run into.
That's
It's the unknown unknowns.
the unknown unknowns. That's a really good one. That's a really good one. If your mind is always stuck in what you know to be working, it can be very difficult to see what isn't working, and you could easily miss that. That's very true. We tend to do things that bias towards the positivity of what we're creating and validating that it's correct in our minds. And yeah, if you're just testing what you know to work already, you could miss these things that you haven't considered. Absolutely. So others have said it's fast. We can check a couple of specific examples you're interested in. Absolutely. To quickly check a single function, yep, it's useful for planning formal tests. Yes, it is. It's a way to explore what those tests might look like. Yes, it can form a basis for a more formal set of tests. Right. Yes. And the other one, yes, it provides immediate feedback. There's a few others. So in terms of the limitations to this approach, working interactively is error prone. We can easily make mistakes. We must reload our function Python terminal each time we change our code, or have that open another terminal and import each time if we want to revise what we're testing. We must repeat our test every time we want to update our code in this way, which can be very time consuming. We need to rely on memory to keep track of how we tested our code unless we write something down. But if we start writing things down, it's probably better to think about a better way to do the testing. Yeah, so and once we close the Python terminal, we lose all the test scenarios we've tried. And yeah, so it's kind of prone to error. It's not ideal. It's not a formal approach to doing this. Okay. Right. So what we can do is do things in a more formal way. We can overcome some of these limitations by formalizing this process. So a more formal approach to testing our code is to write dedicated test functions to check it. So these test functions run the function we want to test. They target the function with known inputs. They compare those inputs, the result of processing those inputs with output we know to be correct. And then we raise an error if there's a discrepancy. Okay. And we record these in a test script that we can rerun on demand. Okay, so we're going to explore how we could do this. So what we're going to do is we're going to write some formal tests for our text to duration function. So what I'd like you to do is to create a new file in the root directory for the moment called test underscore code.py. Oops, right. So I'm just going to create that here. by clicking on the workspace bar here and clicking on plus and creating a new file, which is going to be test_code.py. Press enter, and you should get that popping up. So once you've got that there, then we'll proceed. If you could give us a green tick as before, red cross, of course, if you're encountering any issues creating that. Right. Okay. Right, I think we're about there. Right, so what we're going to do is we're going to start writing some tests, but the first thing we need to do is do as we did in the terminal, which is to import our function from EVA data analysis. So from EVA data analysis, import text to duration. And you can see here that VS Code is being very helpful and telling me, oh, I've seen that, I know that. You can just press tab and auto-complete that, which is kind of useful. So hopefully that happens for you as well. And then what we're going to do is we're going to create a single function called test_text to duration. So yeah, an easy mistake to make would be to get the S and the X mixed around there. Okay, and we're going to test with an integer. So we're going to give this test function a name, which is kind of descriptive to the kind of test we're writing. And we're going to give it an input value into our test, being very explicit here, of 10. So as we saw, we used the terminal to determine this was a reasonable test. It's certainly an integer of a sort. And what we're going to do is we're going to call our text to duration function with our input value and check it's equal to 10. Now, this is a kind of rather unique thing that doesn't happen in all languages. But what this is going to do is it's going to take this condition, evaluate the condition, and either true or false will end up in test result, okay, in this particular case. Okay, so we're just checking that text to duration called with that input value is equal to 10. And the result of that, true or false, is going to be in test_result. Okay, what we want to do is we want to know, it would be nice to know whether the test passed or failed, right? So what we'll do is we're going to create, we're going to print out the result of that. So very explicitly here, we're saying text to duration, called with 10, is it equal to 10? And then what we're going to do is going to output the result of that. Now, I don't know if we've covered this already, but this is using print statements of a particular type called a formatted string. So what we do is we put an F at the start of the string to let it know this is a formatted string. And formatted strings can contain the contents of variable names, right, in this format. So we use open curly brace, close curly brace, and within that we can put our variable name, and the contents of the variable will be substituted when that is printed out. Okay, so that's kind of handy. It's a nice way of just, injecting the contents of variables into our strings as we're printing them out, or using them for any other purpose indeed. Okay, then what we want to do after that is we want to run that function, and handily autocomplete is doing that for me. Okay, right. So that's what we should end up with. So once you've got to that point, if you could give us a green tick, that would be great. And of course, if you're having any issues or have any questions, feel free to put them in the chat or let us know. So just a couple of possible gotchas. So you'll notice here that we're using double quotes to contain this big formatted string, but using single quotes here. Okay, if we were to do something like this, that would be incorrect. Okay, because this would mean that the string would be terminated at this point, which is not what we want. And we're just using single quotes there, which we can use within a double quoted string like that. Okay. Right, so I'm aware that's a fair bit of typing, so I'll give you a couple of minutes just to type that in. So we have our input value here, which we're passing to our function. We're checking it equals 10, and we're outputting the result. So yes, green ticks when you're ready. If you're running into issues, just let us know. So just out of interest, if anyone's used any Python unit testing frameworks at all, feel free to type it into the chat. It's always useful to know if anyone's had experience with any of these before. If you haven't, obviously, absolutely fine, because that's kind of what we're learning today. Right, I see someone has an issue, so feel free to let us know what that is in the chat or to shout out, raise your hand. Yeah, so what appears to be the issue? Let's see. So Stephen, it looks like you're having a problem there. Is there any way we can help? It looks like is that now working for you, Stephen? I see you've removed your red cross there. Okay. Good, good.
Good.
Go on,
Go on,
Stephen.
Stephen.
Hi, it's all good, thank you. I was just responding to your question about whether you've done something similar. Haven't done. That's why the cross. Thank you.
Okay.
Okay, no problem at all. Right. Okay, yes, I'll be clearer about my questions and response modes in the future. Right. So it looks like everyone's there. Excellent. I see someone's used PyTest. Okay, that's good. So what we're going to do now is now that we've done this, we're going to run this piece of code. So what I'd like you to do is to exit the Python interpreter, as we did before, exit, open and close parenthesis. And then what we're going to do is we're going to run, that particular piece of code that we've written, test_code.py with Python interpreter, so Python 3 test_code.py, and we can see that it comes back and it says it's true. And this is great. So this is checking that this is working with that particular value, and it comes back with the expected value, which is great. So this is an example. We're using a print statement to report it out. However, this does not meet our requirement to raise an error if the function's output does not match the expected output. It means that we must carefully read our test function's output to identify whether it has failed. Okay, so this isn't ideal. We need to visually check that these things are right. And of course, we're prone to error. If we had like 20 tests, it'd be very easy for us to miss one false that came out of a series of these tests. So we need to ensure that our code raises an error if the function's output does not match the expected output. So we can do that using something called the Python's assert statement. Now, the assert statement in Python checks whether a condition is true or false. And if the statement is true, assert does not return a value and the code continues to run. It doesn't do anything other than allow the code to run. However, if the statement is false, we get an error, an assert error. Okay, so let's rewrite this test to use assert. Okay, so what we're going to do is we're going to do this. So I'm just going to change this around a bit to be assert that this is equal to 10. So as before, very similar. We don't need the print statement anymore. We're going to get rid of that. And then I'm going to save that and we'll end up with this. Okay, so here's the bit we've effectively changed. We've removed that that following print statement.
Hi, Steve.
Oh, yes.
Sorry for interrupting. Can you please repeat how we reach to assert removing the print and why? I just missed that. It's a little bit fast.
No
Thanks.
problem at all. No problem at all. So what we had before was something that looked like this, and we were using print to print out the result. So when we use the assert statement in Python, basically it gives us a very similar kind of response. What it will do is if this particular condition is false, what assert will do is it will give us an assertion error, right? And effectively tell us if the test has failed. Right? If we use assert and this condition is true, so it passes the test, it won't do anything. Okay, so we can assume if we don't get any error at all, that the test has passed. Okay, so if I put this back to using the assert, and this makes our code simpler and means that we don't need to include a print statement. Okay, because what will happen is it'll either give us an error or it won't do anything. So I hope that answers your question.
Yes, so is it like it's basically doing what the print is doing, just that we are doing less typing? Or is
Basically,
there an added advantage?
that's basically it. There is another advantage as well, which we'll come to in a minute. But basically, yes, it means that we don't have to print out what the result of that was, because assert would effectively tell us that, right? And hopefully that will become clear in a moment, and you'll be able to see. But if it doesn't, feel free to we'll revisit this and clarify further. Does that sound okay? Okay, great. Okay, right. So what we've done now is we've shortened what the code that we're writing as well. So things are becoming a little simpler as well. And the other thing we're going to do is we're going to add another test. Okay, so now let's just write another test, which is something that looks like this. Test text to duration, again, being very explicit. I do apologize. I'm going to move that up to here. So sorry if that means you have to move that up. And we're going to test a float number. Okay, so we're going to assert that calling this function as we did before, and the good thing here is we can use tab completion to complete that, is 10.15 is equal to 10.25. So 10:15, quarter past the hour is unsurprisingly should be equal to 10.25. Okay. Now, the other thing we need to do, of course, is add in the call to that particular function. And again, I'm typing this out and you can see that it's giving me an autocomplete. So I'm just selecting the right one. And we end up with our code that looks like that. Okay. If you've got to that point, feel free to give us a green tick. Then once you've done that, save the file. I'll give you a little while just to type that in. So when we run this code, what we hope happens is that each of these functions will be called, and each one of these functions will then have these assertions. And if one of them is wrong, then we'll have the assertion tell us that one of them is wrong, because we'll get this error. Okay. So the advantage here is if something is wrong, it's going to give us an exception, and this code will exit, okay, rather abruptly and give us this error, which is, in no uncertain terms telling us there's a problem, okay. And this is better than what we had before, where we had to visually pass and understand the output from those print statements, okay, which of course is prone to error. Don't forget to add in the call to the float function as well, just down there. For those of you that have seen PyTest before, this may start to be looking a little bit familiar. All right, I think we're nearly there. Again, any problems, questions, let us know.
It seems like it's showing some error when I give 10.25. It's just me, or am I doing something wrong?
Interesting.
Not sure.
Right. So if you could, I'll tell you what, could you copy and paste that particular line from your code and put it into the chat? Now, it looks right to me. You're using single quotes, which is fine, because it's just another way of describing a string.
Okay.
So whereabouts is the error, just out of interest?
0.25.
Right. So how's the error presenting? Is it just showing you in VS Code that there's a problem?
It's
Or are you
saying
or are you running?
assertion.
Okay.
It's saying I'll just paste.
Okay.
So
All right. I
I-
think I understand. So you're actually going ahead. You've actually gone ahead and run the code, have you?
Okay. I shouldn't run, is it?
No. That's fine. That's fine. Right. So yes,
Good.
it's
Okay. Yeah.
that's fine. It's equivalent of reading ahead, but no, that's fine.
Sorry. Apologies.
No problem at all. No problem at all. And someone indeed has actually identified the error already. Okay, good. So, okay, so this is actually what we expect to see. So for those of you who have done this, feel free to now run this again, right? And hopefully, yes, you should see this assert error. So I suspect that's the one you were seeing. Is that correct? Yeah. Okay. So this is actually what we wanted to show you, right? The really good thing here is it's telling us something is wrong, right? Because this is correct. We know this to be correct, right? This is what should happen, but this is telling us this is wrong. So yes, you guys really are really on the ball today. This is great. And yes, there is a reason why this is actually failing for us. Okay. And that is that if we look at our text to duration function, you will notice that the duration in hours, the computation that actually does the bit that converts the minutes, is not quite right. It's dividing by 6, but it should be dividing by 60. Okay, so there's an error in our code there that is correct. And as Marina quite rightly pointed out, this indeed, yes, should be 60 and not 6. Okay, if we want to get a decimalization of this, we need to divide the minutes by 60, not by 6. So already this set of tests has actually shown that this is incorrect. Okay, it doesn't tell us where the code fault is. It tells us there is a fault. We still have to locate that issue. Okay, but it just so happens we can look at that and just go through the code and see it and fix it. So what I'd like you to do is to fix that issue. All right, it's by replacing the 6 with a 60 and just save that file. All right, so you can do file, save, or you can do if you're on Mac or Windows, you can do Windows Mac key and S. Or if you're on Linux, you can do Control S, okay, if you want to quickly save it. And then we've corrected the code. So now what we do is we rerun our tests. Right, okay, so we're not getting any output now, which means that each of these assertions has passed, okay, which is really good, right? That means that these tests have passed. So this has been useful already. It's helped us to find an issue, fix the issue, we rerun our tests, and now we can see that the behavior is indeed correct, okay? So if you've been able to get to that point, feel free to give us a green tick. And if you have any questions or problems, please let us know. If any of that went by too fast, Marina says, "Oh, sorry, no, that's fine, it's fine." It just shows, you know, you're just looking and investigating the problem, which is showing initiative, which of course is great. And Alex quite rightly points out, it's really important to note that this subtle error would not have been spotted without the test, as the code would run without error and show a graph, which would be an incorrect graph. We would not be able to spot the error in the graph just by looking at it. As we said earlier today, you know, humans are really good at checking the visual, but it doesn't always mean we're going to catch things in the visual either. You know, so on graphs, particularly with a lot of a it can be a very muddled affair, very difficult for us to check if the graph is correct. So even a visual inspection would not have been able to easily detect this, right? So yes, and Alex suggests trying it yourself. So what you could do is you could go back and reintroduce the error, run the code. So I'll just reintroduce the error, and this is what we get. Okay. All right. So right. So if we can't see that there's anything particularly wrong there, right? That's rather scary, right? And if we now put it back to the correct one and run that again, can you see any differences? I certainly couldn't. Right? I couldn't see any differences there. Okay, and this actually elucidates the danger, right, of having this kind of error. It's very subtle. It is incorrect. It could lead us to wrong conclusions if it was used to generate other data. Okay, so we need to be careful, and this is where testing can really help us. So we fixed the error, and okay, so let's try something else now, right? So I can see nearly everyone's got up to that point. That's good. So we're going to try something else. We're going to try a different float. Now we could create a different unit test here, and indeed we probably should. All right, but just for expediency for the training, what we'll do is we'll just change this to be 1020. Right now, that means it's the third of an hour, right? So we think, okay, no problem. That's 10.3 recurring. I think that's 7. Okay, so put in 10.333, And what we'll do is we'll rerun our tests, right? Make sure you run test underscore code, okay? Right, so this time things are a little different. Now, we know this should be correct. By our reasoning, this looks correct, okay? But the problem is that the division will never create a number that will match this, okay? Because this is 10.3 recurring to infinity. And unfortunately, that is not ever going to be equal to what we get out of this, because we can't specify in this way all of these correct digits to that level of precision. So this means we are going to get this problem. So if you've seen that error, as I have, please give us a green tick, okay? The problem here underlying all of this is the representation of irrational numbers is typically not exact, as they do not have exact binary representation, right? So we can't use this simple double equal sign to do this. So what we need to be able to do is to specify a tolerance, right, in the correctness of this. And so what we can do is use a little trick to do that. What we want to check is whether the result of this function, right? Oh, we have a hand. Yes.
Just a quick request from one of the participants to increase the size of the font, Steve, please.
Oh, yes, we can do that. Crikey.
Thank
Okay,
you.
all right. It's hopefully that's big enough. Right. Okay. All right. Okay, so hopefully you've seen this error. If you've managed to see the error, if you could give us a green tick, that would be great. If you're having an issue, feel free to brilliant. Okay, thank you. Right, good. So what we can do is we can use a little trick here just to re-specify this. Right, what we can do is we can take the absolute value of this minus the value we wish to check for, right, and check that this is within a particular tolerance, right, of 1e minus 5, right? So that's basically to 5 significant digits, I think. So effectively, we're using this trick where we're deducting 10.3333 from the result we get from this, and then making that an absolute value. So giving it, whether it's negative or positive, we're just making it positive and checking it's within that. That's a little trick you can do to check that something is within this particular tolerance, okay? We could increase the tolerance if we wanted, okay? But we'll just have it to 1e minus 5, okay? Right, so if we now run it, fingers crossed, I've typed that incorrectly, then we should find it now actually passes, okay? Right, okay, so if you got to that point, give us a green tick, and then what we'll do is continue. So you may have noticed we've had to repeat a lot of code to add each of our individual tests for each test case. You may also have noticed our test script stopped after the first test failure, and none of the other tests after were run. So to run our remaining tests, you would have to manually comment out our failing test, rerun the test script, or you have to fix each of these issues in turn, right? But the problem with this is as the code base grows, testing in this way becomes cumbersome and error prone. And it also means that we're only ever going to get the result of the first failure. We won't see all the failures at once. And these limitations can be overcome by automating our tests using what's known as a unit testing framework. So that's what we're going to look at now, right? So okay, so unit testing frameworks can automatically find all the tests in our code base, run all of them so we don't have to invoke them explicitly, or even worse, forget to invoke them, and present the test results as a readable summary. So we're going to use the Python testing framework PyTest, right? Now, PyTest is pretty much the industry standard. It's de rigueur really for doing unit testing. It's incredibly popular, very well established, excellent documentation, incredibly well maintained, has a lot of it's easy to get to use to start with, I think, realistically, at least certainly more than other unit testing frameworks comparatively, but also it has a lot of sophisticated abilities and functions you can use for doing testing. Okay, so that's the one we're going to use. So let's see. What we're going to do is we're going to install some other packages into our virtual environment. So we're going to do Python 3 on the bash command line, Python 3 -m pip install. So you may recall we did this earlier for installing NumPy and matplotlib, PyTest and PyTest pytest-cov. Okay, so we're installing pytest, but we're also going to install pytest-cov, and we'll look into that in a bit later. Okay, that's basically going to help us determine how well covered our code is by our tests that we write. Okay, so once you've done that, if you press return, hopefully what you should see is Python pip basically going away and installing pytest and pytest-cov into our virtual environment. Okay, so if you've managed to get to that point, if you can give us a green tick, that would be really handy. If you've encountered any problems or errors, feel free to let us know. I'm just going to put that command back up there so you can see it. So I'll give you a minute to type all that in. Of course, depending on your bandwidth, internet connection, you may find this takes a little while. So it looks like someone's already had an error. So I think what you needed there, I think I've spotted an error, is pytest-cov. I think you had ptest-cov there. So if you change that to be from ptest-cov to pytest-cov, fingers crossed that should fix it for you. It looks like there's another package that's called ptest-cov, which isn't particularly helpful if we make a typo. So if you try that again and let us know if that works for you. Brilliant. Okay, good. So green ticks if you've managed to get to this state. So I see that five of you have 6, 7. Okay, right. Again, if you have an error or an issue or a question, let us know. Right. Okay. So, right. Let's see. So yeah, we need to make sure that our tests are ready to work with PyTest. Okay. Now, the way the PyTest works is it automatically discovers tests based on specific naming patterns. Right. So it looks for files that start with test underscore or end with underscore test.py. Then within these files, PyTest looks for functions that start with test underscore. So our test file already meets these requirements, as it turns out. So there is nothing to do here, right? However, our script does contain lines to run each of our test functions. And since PyTest will run these functions automatically, we don't need to actually call these functions. So what we're going to do is we're going to remove these two calling functions. Okay, so PyTest will call these automatically. So we're just going to delete that from our test code and save the file. Okay, that's the first thing we're going to do. Now, the other thing we need to do is, by convention, it's good to put your test files in a separate directory, and that's a tests directory. So what I'd like you to do is I'd like you to make a new directory from our root repository directory called tests. And on the command line, we can do that in bash by doing mkdir space tests. Okay, so that makes our new directory test. And if I do ls after that, you can see that tests has now appeared. Okay, and then what I'd like you to do is to use the bash move command to move a file from one place to another. mv test underscore code.py into tests, but also rename it specifically test underscore EVA underscore analysis dot py, right? And press return. So that's going to move our test file into the test directory. So we need to reopen it. Okay. So if I now close that and reopen it here, we should have the same contents, but of course it's in a different file now. So if you've managed to get to that point, feel free to give us a green tick. Again, questions or problems, let us know if anything went too fast. So if I do ls space tests, I can see that I have test underscore EVA underscore analysis.py sitting there. Okay. I'll give you another little bit longer just to finish that. So I'm going to put something into the chat, which is, I need more time. So if you do need more time, feel free to give us a thumbs up on that comment that I've just put into the chat. So yes, this is kind of like one of those checkpoints that's important for us to get to. Okay, so if you do need more time, feel free to give us a thumbs up to that, and yeah. Otherwise, we will proceed. Right, okay. So, right, so we've got to this point now. So we have our renamed test file, right? Now, before we rerun our test using PyTests, there's a much neater way of writing this, okay? Now, this is a very kind of mathematical specific using low-level Python functions to do this, but PyTest actually gives us a function to check whether a number is approximately the same as another, okay? And this can be very, very useful for floats, right? So what we're going to do is we're going to change our test code to import PyTest itself, which gives us access, to a whole load of PyTest specific testing functions. And what we're going to do is we're going to change this to be, I'm going to get rid of this. We don't need that anymore. And we're going to say 1020 is equal to PyTest dot approx this value, okay? So we're just going to say, yeah, when we call this function, is it equal to approximately this, And this is really handy. It's now a lot neater, I think, and less cluttered than what we had before. It's more consistent to what we had before. It's simpler. It's a little easier to read and understand. Okay, with the ABS, we had to work out what that meant. And to be honest, we should have put a comment there saying what that was about. Okay, but in this case, this is a little easier to understand. Okay, so if we get to that point, so the other thing is we can also add some inline comments to clarify, yes, what each test is doing and expand our syntax to highlight the logic behind our approach. And this is a really good idea because this really helps us to understand what we're actually trying to test. And in some cases, this can be very, very difficult. So you may remember yesterday, I think we looked at doc strings. So if we create a doc string, I'm just going to create a doc string here. And I'm just going to put in that and test that text to duration returns, if I can type correctly, expected ground truth values. Now, I note that it's 10:15, so I think what we'll do is after we've done this little bit, we'll go to a 15-minute break, okay? With a so we're going to test that text to duration returns expected ground truth values. These are known values we know to be correct for typical durations with a non-zero minute component, being very explicit about what we're testing in this one. So docstring, we basically use 3 double quotes to open and 3 double quotes to close. Make sure the indentation is the same. Okay, and we can do the same for this one. And actually what I'm going to do is change this to be 10 like this. I'm just going to return that to be double quotes so we're consistent with the use of quotes. So it looks like this, okay? Right, I'm also going to put another doc string in here, which is to say we're going to test that text to duration returns expected ground truth values for typical whole hour durations, okay? Right, and I'm going to save that. So I'm just going to leave that there for you to fill out. And I see we have a question there. Right, yeah, so what's your question?
Is it regarding the raised hand?
Oh, yes, please. Yes, it looks like you have a raised hand.
Yeah, so sorry. So I just was about to ask that can you just please explain what this line is doing, line number 9, assert text to duration.
Oh, yes, of course. So apologies if I went by a little fast. So what we had before is, you may remember, we had this use of the ABS mathematical function to check whether a value was within a particular tolerance. Okay.
Yeah.
Now,
Yeah.
that's one way to do it. Okay. And that certainly would work. Okay. But the other way to do it is to use a series of functions that are provided by PyTest to check whether values are approximately the same as other values, right? So this can be very handy because it's basically a shorter way of actually saying that is this value that's returned from this approximately equal to the value that we want. Okay. So it's accomplishing exactly the same, but with the benefit that we're using an established library to do this check for approximation. And also it simplifies it a little bit, because before we had to take this value minus 10.33, do an ABS on it, check it's within a certain tolerance. So this is a little bit neater and a little bit more explicit. Does that make sense? That's a good
Yeah, that makes sense. Yeah, thank you. So the approx, so that's the advantage, because it is a standard library. We don't need to worry about how approximate it is. We can just rely that it is fairly approximate, so that we,
Yeah.
Okay.
Exactly. And indeed, PyTest provides a lot more features for this kind of thing, where you can test equality to a very specific number of decimal places as well, if you wish to do that. So we're just using this to say, hey, is it approximately this? But yeah, there are various other ways to test for equality, given the type of value that it is. And this is one of the things that comes up in unit testing quite a bit. But yeah, that's exactly it.
Thanks very much. Thank you.
So Marina's got a question: how do we import a function from a file in a directory above? Now that's something I haven't seen in a while, and I think this is sometimes an issue, right? So if you want to import a function from a file above, like say for example you were in a directory and you want to import a file from somewhere else. So the way that PyTest is working is it's working out where this code is located in order to be able to get this function from that particular file. But in the general case, I think that's what you're asking. And I'm not sure this works, but you used to be able to do this. I don't know if this works anymore. I'm not sure it does. I'm just going to comment that and see if that works. I don't think that's going to work.
Without the slash should work.
Oh, without the slash. Like that. Yes, thank you. It's been a while since I've done it. Okay. So I think that's how we could do that. Okay. And then that would then work. So that would check for that file in the directory above. Okay. So it's similar to how you do cd space ... Okay. Thank you for the help there. Right. So that's the problem that you're seeing. That's okay. So yes. So Marina, you're quite correct. That is an issue. But do not fear. We have a solution. Okay. So right. So what we did before, you may recall, we ran our test file explicitly. Okay. But we're not going to do that this time. Right. So what we're going to do is we're going to use Python to run it for us. Okay. So what we're going to do is we're going to do Python space -m PyTest. Okay. We'll just get to this point, then we'll go to a break, I promise. All right. So I'm just going to press return. Right. And hopefully, in this case, Python 3 for me, we should find it runs. Okay. And Marina, hopefully this sorts your issue for you. So instead of running that Python file directly, we're now using PyTest to run that test file. So as we said before, what PyTest will do is automatically look for files that are in a test directory, or indeed in our root directory, that start with test underscore. And then within those test underscore files, we'll look for any functions that start with test underscore, and then it will run those particular functions for us. Okay. And then what happens is PyTest will then present us with this report of what's happened. Right. And we can see here that we're getting, in my case, I'm getting this in a colored terminal, which is green, and it's saying that these have passed. So a dot and a dot, the two tests that we have here, represent the two tests that were run as part of running PyTest. So if you've managed to get to that point, If you could give us a green tick, if you're still continuing to have issues, please let us know. So Marina, by using Python -3 space -m space PyTest, does that now work for you? Hopefully that does.
So I have a question. So are we going to execute Python 3 M PyTest from within the Spacewalks folder or from within the test folder?
Good question. Good question. So we'll actually be running this from within the Spacewalks folder in this particular case, right? So what PyTest is doing, we're basically running a program, right, called PyTest, and PyTest will be looking in our repository for directories that are named tests, yeah, and then it will look within tests and identify that we have a test file sitting within that directory automatically. And then it will run each of those test underscore functions in that file. Yeah. So this means that, we don't need to point it at the tests directory explicitly. It'll automatically look, right? But it's a very good question, because what we can do is we can say explicitly, if we want to, on the command line, which file we wish to run, if we wish to do so. So we can say Python 3 -m PyTest space tests /test EVA and analysis.py, and it could do it that way instead, right? But if we do it this way, it's all.
Okay.
Oh, Steve, you just lost your sound. Or was it just for me?
Yeah, no, I couldn't. I thought it's for me. Okay.
Oh, okay, so apologies if my
Okay.
connection's
Oh, you're
not great.
back.
Oh, good. Oh, thank God for that. So
Thank you.
yes, very quickly.
So,
Yeah,
so
go
that
on.
means, sorry, I hope I'm not asking too many questions. So,
No, that's fine.
is it like that the tests, the name tests, is the default directory where the PyTest goes to? And
Yes. That's it
okay,
exactly. So,
yeah, thank you.
and it's also, it's established convention and also where PyTest will look. So, yeah, PyTest will look in tests to check for any files that start with test underscore explicitly. So we don't
Oh,
need to,
right.
we don't
Okay.
need to. So it's automatically checking that for us, which is kind of
Okay.
nice. And if we had more than that one single test underscore file in that tests directory, it would execute all of those files for us, run all the tests. So we don't have to specify all of them individually, which is kind of handy, right? So yeah. Okay, good question. Okay, right. So unless there are any other questions at this point, I think what we can do is we can go to a break for 15 minutes. I think you all deserve a very well-deserved break. So we have been going for a little while. I do apologize for that. Okay, so what we'll do is we'll come back at 10:40. Okay. If you do happen to have any other questions, feel free to put them into the chat and I'll do what I can to answer them when we come back. All right. Okay, right. See you in 15. Right. Hi, everybody. So we're back to, let's see, it's now 10:40. So I've put something into the chat, which is a statement. I have returned from the break. So if you've returned from the break, feel free to give us a thumbs up there, just so I know that that's what's happened. Okay, I think we might be waiting for a couple more. So, hi everybody, if you just joined us, if you have now returned from the break and are ready to proceed, there's a comment in the chat. If you could give us a thumbs up, just so we know that we can proceed, that would be great. Or you can just comment, hey, I'm back from the break. That's fine as well. Okay, it looks like we're probably just about ready to proceed, I think. Okay. Right. Okay. So, where do we get to? So we got to the point where we've been able to successfully run our tests, and they have successfully passed. Okay. Now, before I proceed, I'm just going to ask a question in another question in the chat, which is about my pace. So, Steve is going too fast. Steve is pacing about right. Sorry for the English there. That's not quite right. Steve is going too slow. So could you give us a thumbs up on the specific one that you agree with generally? Feel free to say, hey, look, it's going too fast. That's what we're here for. Happy to slow down a bit if that's what you'd like. But yes, please feel free to pick one of those. Be honest, be brutally honest. So it looks like I'm going a little bit too fast, and but roughly about right. Okay, all right. So thank you. That's very useful to know. Right. Okay, so we got to the point where we're able to run PyTest over these tests that we have now. So we're beginning to have a set of tests that are really good, that are starting to shape up in a way that we can run them repeatedly, and get results of what is happening. So we've seen what happens when the tests are successful, but what happens when they fail? Well, you may remember we had that bug in EVA data analysis where we had it divide by 6 instead of 60, right? So what I'm going to do is I'm going to put that bug back, all right? I'm going to go back to EVA data analysis.py and change the 60 back to a 6, save that file, and rerun PyTest, okay? Right, so I'm going to press enter and we'll see what happens. Right, okay, so now what we get is something that looks a little different. We have a comparison failure, right? And we can see that there's an assertion error that is being presented here, okay? And we can see that it's happening, test text duration float, okay? So in our test file, it's telling us at line 9, there's an assertion error, and we can see it's within that function. It's asserting that 13.3334 is effectively not equal to 10.333. Okay, that assertion has failed. All right. So we can see that this is where the error is occurring. Okay. So this is good. It's told us that is actually a failure. It's also telling us that one of the tests has passed. So the good thing here is it's actually gone ahead and run both of these tests. Okay, it hasn't just bombed out of the first one. It's run both of them, and it's giving us a report that one of these has failed. All right. Okay, so that's actually kind of handy, right? Put that a bit bigger. There we go. The other thing is, I can see that it's trying to be clever here. Okay, so Okay, so this is the full output of what I actually got. You will see that it's also telling us a quick summary here at the top, as we saw before, but now it's giving us a big capital F, telling us that the first test failed, the second one was a dot which was successful. So it's giving us a quick summary there, and then it's telling us the detail about the failures of the test and how they failed. So it's being very specific here. Okay, so that's kind of handy, right? And we can fix our bug again, put it back to 60, and save the file, and then rerun our tests. And again, it goes back to being successful. Okay, so if you manage to get to that position, feel free to give us a green tick. Again, got any questions? Let us know, or any problems. Right. If you need a bit more time, feel free. I can give you an extra little bit of time just to do that. So, right.
I don't think it's so important, but I'm getting lots of warnings about matplotlib.
Interesting. What kind of errors are you seeing? You feel free to paste them into the chat.
What is it? High passing depreciation warnings. One of should be one underscore of. They're just like warnings for the different functions in Python, I think, or in Matplotlib, sorry.
Yeah. So those are deprecation warnings. I think what it's saying is that the particular way in which matplotlib is being used in the future is going to be deprecated and taken out. It's giving you a warning that whilst it works now, later on, there's a chance it won't because it's planned that it's going to take it out. So this is kind of useful because when libraries kind of evolve and change, sometimes the interface changes and things can break. But what they're doing is giving you this warning that in the future, this particular way of using it is going to not work, right? But it's working at the moment. This is usually a hint that what we should do is look at the preferred way of calling matplotlib and adapt our code to match that particular way of doing it. So in this case, it's using, reset cache is deprecated, use reset cache. So this isn't something that we are doing. This is probably something to do with the way that the Python library is using the underlying matplotlib library. So I suspect what will happen is that the maintainers of the matplotlib Python library will update how they use the underlying matplotlib to correct that deprecation error, and it will no longer be seen. Okay, that's what I would say is probably happening. So yes, it could be that you're using an out-of-date library, as Alex is saying. So if you're using an older version of matplotlib, good idea to update that as well. Always good practice to make sure that you're testing against the most up-to-date packages where you can, where it makes sense to do so. Okay.
Yeah, I did have a problem with it yesterday, so I'll try updating it and see what happens.
Okay, no problem. Someone's asked, not directly related, but would you mind showing your autocomplete AI assist settings at some point? Mine is overkill and it's very annoying. Yes, it is. Oh my God. AI has its place. It's actually a much smaller place than people think it is. But yes, it can be very annoying. So what you can do to turn that off is you can see down here, there's this little icon that looks like two people with a cross through it. You may find you don't have a cross through yours. If you click on that, and then you see the problem here is I've got Copilot Pro, but what you should be able to do is click on this little icon here, which should present in some way. And if you click on that, oh, hang on, no, that's not it. There's a way to turn it off, and I did it yesterday, and oddly, the interface has now changed. So
Is there this inline suggestions? Is that maybe it, Steve? Sorry, just below
yes.
the bar.
Oh, they changed it. Right, okay, yeah. So you'll probably find you have these set. Okay, so what you can do, because it can be just a little bit annoying, is just disable those for now, like that, and you can see it's disabled. So the last time I changed that, I had to click on a specific button to bring up the inline suggestions dialog box, but they're changing VS Code and Copilot so frequently, it can be very difficult to keep up with how best to do it. So yes, thank you, Alex. So you probably find there's a setting there for inline suggestions that you can just untick. Does that answer your question? Does that help? I hope it does. It can be a bit persistent, can't it? Yes, let us know if that has or has not resolved your issue there, Phoebe. Have a look in VS Code settings. Yes, you could find it. You could find it there. And if anyone else has another solution, feel free to put that in the chat for Phoebe as well. Thank you. Okay, right. Okay, so what I'd like you to do now is an exercise that you will find in the shared document. So if you go all the way to the end, you will see there is an exercise for about 15 minutes. So a colleague has asked you to conduct a pre-publication review of their code, which analyzes the time spent in space by various individual astronauts. You tested their code using PyTest and got the following output. Inspect it and answer the questions below. So you'll note that there's some example PyTest output here, which you can go forward and have a look at. And there's some questions at the bottom. How many tests has our colleague included in the test suite? The first test in test prepare has a status of S. What does this mean? So yeah, feel free to search online to find out. Always a good skill to have is being able to find out what things mean for using software. So do a search, see if you can find out what the S means for PyTest in that output. Answer how many tests failed, and also have a look at why you think test total duration failed and why test mean duration failed. Okay, so there's a few questions there. So I'm going to give you 15 minutes. Feel free to answer these questions for yourself. Don't put the answers into the chat. Sorry, into the shared document. Okay, we'll come back and we'll see how you did. All right. So Philly said that yes, you can solve that auto-complete assist setting by doing Control Shift and P to search for GitHub Copilot, and then you can disable the inline suggestions. So using Control Shift P can bring up the command palette, search for GitHub Copilot, and then disable the inline suggestions that way. Okay, so I think for me it's Mac Shift P, and then let's see. There you go. So yeah, so if I do Command Shift P on a Mac, or Windows Shift P on Windows, or Control Shift P on Linux, then it brings up the command palette and we can type in disable inline suggestions and then you can toggle it from there. Brilliant. Okay. Thank you, Philly. Very handy. Always good to point that out. Right. Okay, so we'll come back in, give you some time to do that. If you've got any questions or problems, feel free to let us know. When you've completed the exercise, give us a green tick as well. Okay, just to let us know you finished it. All right. Okay, so we'll come back at, let's say, 8 minutes past 11. Okay. As per usual, yeah, any questions or problems, just shout them out, put them into the chat. So I think the green ticks are transitory, so they tend to disappear after a while. So I'm going to put a comment into the chat, which is I have gone through the exercise. So if you have gone through the exercise, if you give us a thumbs up there, if you've got all the way to the end, or you've done enough of the exercise that you're happy with. Okay, we'll go through the answers after that. Thank you. Right. I think looking at the upticks and the thumbs up together, I think we've got pretty much everybody there, I think. Right. Okay. So what I'm going to do is I'm going to quickly go through those questions and see, let's see if we how well we did. So the first question was how many tests has our colleague conducted? So we can determine that by looking at this here. It says it's collected 9 items, which tells us that there were 9 tests that it's conducted. We can also verify that by counting either any of the entries here as well. So we can see there's 2 Fs, 4 dots, 1 S, and 2 further dots. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's again 9 items. That's 9 total tests. S, so what does S mean? Well, we know what F means. That's a failure, and a dot means success. So what does S mean? Well, I just put it into Google, and I luckily got people also ask, what does S mean in PyTest output? And it means that the error, that particular test was skipped. Okay. So it could be that it was, a test was skipped because it's not functional on a particular operating system on where the tests are run, so it's being skipped. Or it could be that when running PyTest, this skip was explicitly told to be skipped, which you can also do. So yeah. Question C, let's see how many tests failed. Well, we can see that 2 tests failed here. So we see F and F. So 2 tests are failed. First and second test, as it turns out, as we can see here. All right. And let's see, for D, test total duration. Now, that particular test failed because the calculated total duration was out by a factor of 10. Right. Now, importantly, this could be because the test is wrong, or it could be because the code is wrong. Okay, it could be that we're testing against the wrong value. It could be that the value that's being generated is incorrect by our code. So importantly, we should consider whether our test is wrong as well as whether our code is incorrect, or both indeed. All right. So yes, important thing to remember that we're fallible when writing tests as we are writing code. Okay. Right. Now, the final one is test mean duration. Now, how did that fail? Well, let's have a look. We can see down here that we have a line here where the error has occurred, and we can see that there's a name error here that says name length is not defined. And that's because they're trying to get the length of this particular list or other object, and they're using length, and what they should be doing is using len. Which is the correct Python way of getting a length. So we can see here we have all this diagnostic information that we can use to hunt down where the errors are occurring, but of course we have to apply our own brain to understand what the error actually is. Okay, right. I hope that was useful. So what we're going to do now is we're going to continue on to the next bit, which is about test suite design. But before we do, what questions do people have? Feel free to put them into the chat, or shout them out, raise your hand about anything we've seen so far.
Sorry, I think I missed. What was the meaning of the S? Status?
Yes, no problem at all. So yes, so what I did is I put this into Google to find out what it meant, and in this case, Google quite happily gave me a handy answer here that tells that S means that the test was skipped. Sometimes tests are skipped because they've explicitly been told to be skipped, which you can do with PyTest. You can say, don't run this test. It could be there's a condition on the test, which means it won't run if it's being executed on a particular operating system. So for whatever reason, that test was skipped. It wasn't run. We don't know whether it would pass or fail, but it may not have been appropriate to run it, if you see what I mean. Does that answer your question?
Yeah, sure. Yeah, I knew it was skipped, but I just didn't know why. Why? Yeah, okay, thank you.
No problem at all. Yes, it doesn't tell us the reason for the skip. I do not believe in any of that output. So that's something that we would have to investigate to see why it was skipped. It could be the condition's wrong, right? We'd have to update the condition. Maybe we wanted that test to run. So yes, but with anything that isn't a dot, we should probably verify or check the failure. Yeah, which is probably a good way to do it. Yeah, good question. Right. Okay. So we now have the tools in place to automatically run our tests. However, that's not alone enough to properly test our code. So we need to think about, in a bigger sense, what makes a good test suite and what are the good practices for coming up with tests and writing tests. So what we're going to do is we're going to start with a particular scenario. So let's assume that we have a collaborator on our project that sent us the following code, which adds a new column to crew size to our data, right? So what they've done is they've created an amendment to this particular code that we are using, right? And what they're doing is adding a new column to this data called crew size, which contains the number of astronauts participating in any given spacewalk. So how do we know that that works as intended and that it will not break the rest of our code? So for this, we need to write a test suite with a comprehensive coverage of the new code, just to check that everything is working as intended, right? We need to think about this in a bigger way, right? So what I'm going to do is I'm going to paste into the collaborative doc the changes I'd like you to make for the code, right? So these are the intended changes that our colleague is saying that need to be made. So there's the first change is in our main function, right? So colleague code changes, right? So you will notice that there is another line, 2 lines that have been added here. Calculate a comment which says calculate and add crew size to data. And what it's doing there is it's adding a new column, calling a function that will effectively add a new column to our data. So if you can update your main to reflect that change there, that's the first change I'd like you to make. You can copy all of it, or you can just copy the 2 lines that are different. Okay. I should point out, ordinarily, this is not the way we would normally share code changes. We do that over GitHub. Okay. But for the purposes of this particular training exercise, we'll just copy this in. All right. The second change I'd like you to make is to add another function to the end of EVA data analysis.py. Right. Add this to end of EVA data analysis.py. Oops. Yes, I should be using Markdown. Quite right. There we go. And there's another function I'd like you to add as well in a similar way, which is this one. Okay. Now, this is a common scenario and it happens all the time. If you're working in a team where code is being amended by multiple people, you're going to see changes to the code underneath what you're doing, okay? And there are good ways to manage that using version control. But in either event, code is going to change and those changes may not be instituted by you, okay? And so it's a good idea just to check that things are working the way that you would expect, all right? So once you've copied all that in, if you give us a green tick, just so I know that you've amended EVA data analysis, that'd be really handy. Thank you. Right.
Hi, Steve. So
Yes.
the first set of code, where do you add that one? It's in also at
Definitely.
Oh, sorry,
there's a bit of feedback.
Sorry, can you hear me?
I
I can, yeah,
but
there's feedback.
So
So
give
could
me
you
just for a
for a
second.
second?
Thank you. Brilliant. Thank you. So yes, the first bit of code is a replacement for our main function. So in main, you will notice if I just so in our EVA data analysis code, you'll notice there is this here. Okay. So what I'm going to do is I'll demonstrate the making of this change. So I'm just going to copy over the line that is different, which in this case is this one. Actually, it's 2 lines effectively. So what I've done is I've just copied those 2 lines in. The other way to do it would just be to copy the entire main function and replace the existing main code in its entirety. Okay, so that's the first change. Does that make sense? Oh, Stephen, I can't hear you. Are you currently making that change? I suspect you're currently making the change, aren't you?
Sorry. The first one is to change the main code, basically.
The function in EVA data analysis that's called main, yes. So you need to update it so that it looks like the one that's been put into the chat there, the shared document. Yeah. The 2 lines that are different are these 2 lines that I've highlighted. Hopefully you can see that. So basically you could copy and paste those lines in just beneath EVA, this line that reads EVA data. Is that clear? Does that make sense?
Yes.
Great. And then for the second set of changes, you just need to copy and paste each of those 2 functions at the end of. So be careful not to copy in. Actually, what I'll do is I'll remove the markdown ticks there. Make sure when you copy these functions in, you're not copying in the markdown ticks that are also there. Okay, so just copy in the functions, and I'm going to do that now, and I'll show you what that looks like. I'm going to copy both of them in one go. I'm going to put these at the end. So I just copied and pasted them in. If you find that you've got backticks sitting in your code like this, then feel free to make sure you delete those because they're going to make you run into errors basically. Okay.
Thank you.
Okay, so if you managed to get to that point, if you give us a green tick again, sorry, I know we're I'm asking you to do this quite a fair bit, but I just need to be sure that you're there. Oh, I see a hand there. Yes. What's your question? Oh, I think you might be muted. I see you've lowered your hand. Is that all correct now?
There is a question in the chat now about whether it matters if we are pasting the new functions before the main function.
Yeah, that's a fair question. So yeah, it shouldn't matter where you're pasting the functions. However, it's nice to be consistent with our code design. And at the moment, we have a nice high-level main function sitting at the top. Okay, and that tells a nice high-level story of what we're actually doing with our code in terms of calling all the functions. So it would be nice to put the new functions below our main function. Okay, I've put them right at the end, but narratively, it might make more sense to put them after this function because that's the order in which it's being called. Okay, but yes, it's up to you where you put them. Okay, but yeah, logically, it's nice to put them after the main function so we're consistent. Oh, yes, good point. Maybe I've done that a little bit too quickly. That's a good question. It shouldn't matter, but you are right. I rushed a bit there. What I'm going to do is I'm going to move that code that I've pasted to above the main check there. You're absolutely right. Thank you for spotting that. That is a big improvement. The main bit at the bottom should indeed stay at the bottom. Yes, that is the best place to keep that. Otherwise, we don't want to get getting lost in the middle. Okay, excellent. Thank you for bringing that up. Please point out any errors or things that are confusing if I'm making them. Doesn't mean I'm just because I'm doing it doesn't mean it's right. There's a good chance it's wrong. So just let me know. Right. Okay. So I think we're there. Okay. So make sure you save those changes in the file. Okay. So the aim of writing good tests is to verify that each of our functions behaves as expected with the full range of inputs that it might encounter, or at least close to a representation of those kinds of inputs that it might encounter. So it's helpful to consider each argument of a function in turn and identify the range of typical values that it's going to take. And once we've identified this typical range of values, where a function takes more than one argument, we should test the values at the edge of this range, perhaps test at least one value which is in the interior of this space of testing. So when we were testing our functions before, we were testing things like integers. We should test something within that and also test invalid values. So in summary, we should test things that are at the edge of the range, things that are within the range of what we expect, but also test things that are completely invalid, right? And this tests three important parts of our code behavior. One, that it's working as we intend with data that we expect, right? And that's the easy bit to get right. We should also test values at the edge of this range to make sure that it's still functioning correctly with values that are just at the outside, just within this range of expected values, which we expect to be correct, but also invalid ones raise errors, okay? So we're just checking all of these aspects. So this is a really good idea to do in general with when you come to writing tests. So what I'd like you to do is now do another exercise, which is, let's see, unit tests for calculate crew size. I'm just going to copy this into the shared document. Right, okay, right. So what we'd like you to do is to implement unit tests for the calculate crew size function. So our colleague created this new function called calculate crew size, okay? And we want you to cover typical use cases and edge case, right? So use the following template when you're writing your tests. So you'll see that I've copied and pasted some Python code in there as part of the exercise. So this just follows a template that we've had before. Okay, and you'll notice it's got some fix me's there. So the idea here is for you to have a go at writing your own unit tests. And so we've created this, this kind of template you can use. So have a think about what would be the correct answer you would expect to see for a particular test. Also do the calling of the crew size function with some example data, and then effectively do the test with the assert to check that it's as you would expect. Now, just to help you, I can give you an example of how that works in practice in terms of running that. So if I do Python 3 and do from EVA data analysis, import, let's have a look, calculate crew size. So you may recall we've added this function in. Okay, right, now if I do calculate crew size, right, and then give it an argument, which in this case is a list of astronauts. So I don't know, let's give it Lee Rogers. I'm just making up names now. Okay, I think that's correct. And if I press return, it should tell us I've done it incorrectly. Aha, so I just need to make sure I've got that correct, which I have not. Oh, yes, okay. Oh, yes, so it's not as a list. My apologies, it's as a string. So what we do is we pass in, and we can see that if we look at the I believe they have, so if we look at the definition for that particular function, calculate crew size. So the text entry in the crew column containing a list of crew member names, okay? Now, as it turns out, what we do is we give it a list as a single string, right? And we need to terminate it with a semicolon. So if we do that, oh, no, hang on, that's not right.
Do we need a library for the RE? Because I don't like my VS Code also doesn't like it.
You are quite correct. Thank you for spotting that. So what we need to do is we need to import a library in our function called RE in EVA data analysis, right? That's something I forgot to add earlier. Thank you for pointing this out. So I think also what we'll need to do is to import that into our Python interpreter. Then if we now call it, right? Did I forget to import RE? Maybe I need to. Okay. So apologies for this. I think I know what the problem is. if I now run Python 3 again and then use this to import that function again, I think it imports the library that it's expecting to use. The RE library is a regular expression library that's used for string manipulation, okay, which is used by the functions that we're importing. Okay, so if I now do it this time, it should come back with the correct number of astronauts, which in this case is just one. Okay, if I give it two, so I don't know, Judith Resnick, like this, it should come back with two. Okay, all right. So that gives you an idea of how you can call calculate crew size from within your test function. Okay. So feel free to go ahead and amend test EVA analysis with calls with functions that are going to test calculate crew size using that template. So I think what we'll do is we'll give you about 5 minutes just to have a go at that and see how you get on. So while you're still getting on with that, so there's a question from Gunnar, which is, would you recommend collating all tests in the same source file or keep one or topically related tests in a single file? Excellent question. So I think the key thing there is it depends on the scale of the tests and the nature of the tests. So if you're only writing a very, very small script, you could easily put them into one single file. If you're finding that you're getting to a point where the tests are growing and one single file becomes unmaintainable, that's an absolutely correct question to ask. And at that point, yes, it's a good idea to separate them into different test underscore files, each containing their own set of separate tests. And you could have different test underscore files for different aspects of your code base. So if you had, for example, a simple way to do it would be if you had different Python code files, source code files, you could write a single test underscore script which tested each one of those. If you had a more complex code base and there were things that you were testing across it, you could elect to have them organized in terms of the area of concern that you're testing. So it could be, for example, image generation, right? And so you could have a test underscore file that tests images are getting generated correctly, for example, or another one which tested the statistical methods that are being used are indeed being called correctly, or so on and so forth. But yes, it's a good idea to think about modularity for your tests exactly as you would, or very similar to how you would for your actual code base. So you may recall yesterday we looked at modularity and splitting things up. Same thinking applies. Okay, modularity should apply with your tests as well. So yeah, great question. So feel free to have a go at that. Yes.
Sorry, what's the RE again?
So no problem. So yeah, RE is a built-in Python library which deals with regular expressions. So effectively, the library allows you to do string manipulation, so manipulation of string objects in Python. So it uses regular expressions generally to do that. And we don't need to understand necessarily at this point how regular expressions work, but we do need that library for this particular function to operate. If that makes sense. If you're interested, feel free to go and have a look at the documentation for the RE library. Okay, but it does things like it enables you to specify how you'd like something in a string to be replaced. And it has a very, very complex way of specifying what it is you want to change. And it also gives you the ability to search for things in strings as well and return them, which is what this calculate crew size function is using. It's basically splitting up, using the RE library to split up the string by semicolon and return each of those different names in a list. I think the implementation does. So it basically takes a single string and then basically returns the output of separating by semicolon. In this case, it would create a Python list of two items, if that makes sense.
Okay, because it didn't work earlier without this one. So
indeed, yes, quite right. I did miss that out on EVA data analysis. So yes, you do need to include that.
yes, thank you.
Okay, no problem. Right, so if you've had a go at the exercise, you've got through it, feel free to give us a green tick. If you're running into issues, feel free to let us know. Right, so I'm going to put something into the chat, which is I would like more time. So if you'd like more time, give us a thumbs up to that comment, okay? Or if you've completed the exercise or gone through it as much as you would like, feel free to give us a green tick as a reaction. So I can see some people would like more time. Yes, this does take a little while to wrap your head around when you write one for the first time. So I see someone has run into an issue, so feel free to shout out what your issue is, or to copy and paste the error or your problem into the chat. So Jan, it looked like you ran into a problem there, I think. So yeah, what can we do to help?
Sorry, I feel like I don't know if I'm writing my pi test right. So I kind of just put it as assert that the result of calculate crew size with a list with one item is equal to 1, but I'm getting an assertion error after I run the pi test.
Right. So I see you pasted something into the chat there. Right. Okay. Yeah, sorry. Yeah, it does mangle it when you copy and paste it. Actually, feel free to put it into the shared document if you like. That's probably easier. Right, I think I know. So yes, definitely on the right track there. Louis Armstrong, sure, why not? So this is interesting because it's telling you something about how the code is kind of working. You'll notice that the result it got back was 0, and it's expecting 1, right? So interestingly, the code is restricted to the sense that you always must put a colon after the name in order for it to be registered successfully, if that makes sense. So when you're, for example, if you look at my example here, we're constrained to ensuring that we add a semicolon on the end in order for it to be registered. So if I put in Lee Rogers, but oh, I don't know what it's doing there. That's strange. Okay, if I do not include that semicolon, it says 0. Okay, I need to include the semicolon at the end for it to be successfully passed as 1 astronaut. The reason for that is due to the actual data. So if you look at the data, you will notice that where there is 1 astronaut, it will in fact have a semicolon on the end. So it's kind of making an assumption that the semicolon will always be there in order for us to determine how many astronauts there are. So in your test data, you could put a colon on the end of Louis Armstrong, right? So this is an important learning opportunity here, because this gives us 2 choices. We can do that. We can fix what we put into the test when we test it. So we put in that semicolon at the end of that string. Or we could say to our colleague, yeah, we don't like the way this is working. We think this is not intuitive. And this could start a discussion with our colleague about what's the correct behavior for codes to operate, if that makes sense.
Yeah, thank you. Adding the semicolon did fix it.
Brilliant. And Gunnar makes the excellent point that indeed, if we put in 2 semicolons at the end, it will miscount as well by 1, right? And we can keep doing that and it'll keep miscounting, right? So this is a code issue that we might want to take up with our colleague for this particular issue as well. Excellent point, Gunnar. Thank you. Right, yes, because that could be considered incorrect, right? Because that's only 1 name, despite the fact it's got all this. So maybe just counting semicolons is not a safe assumption. Okay. Right. Okay. So let's see. If you've managed to do the exercise, feel free to give us a green tick. Okay. Let's see where you are. Okay. Oh, good, good. I think we're all there. Right. So I'm going to show you what I did, or at least what was prepared before. So I'm going to create a new function, which is test underscore calculate crew underscore size. Okay. You can just see what I've done. You can feel free to amend your tests if you think this is better. Yours might be more concise, might be better. Test that it returns ground truth values for typical crew values. Okay. So I'm going to do something very explicit here and say actual results, which is the thing we're actually going to obtain from our function. Calculate crew size. And you'll notice that I can't call this function at the moment because it's not being included. I need to import that. So I'm going to say, let's see, calculate crew size. So I'll put that in there to make sure it's being imported so I can call the function. Okay. And then in here, I'm going to put a name, which is Valentina Tereshkova. All right, so as we've already seen through testing and exploring this code and then these modifications, we need to put that semicolon at the end. Okay, now the expected result we would want, which obviously is up for contention depending on how our discussion with our colleague goes, but at this point in time, we expect it to be 1. Okay, and we're going to do that assertion. Right, actual result is equal to the expected result. So that's how I've chosen to format this test. So that's good. But of course, there could be other things that we want to test for. So let's test another one. So actual results again is equal to calculate crew size, Judith Resnick, Sally Ride. Okay. And then that's 2. So we should our expected result should be 2. And then we need to assert again that our actual result is equal to the expected result. Now notice we've put, just trying to be clever there, well, I'm mistyping. So again, we are doing the same things we did before. And in this case, what we've done for this particular test is we've put 2 tests in the same function. Okay. Now, we could split this into 2 functions so they're separate. And probably that would be a good idea. But we're going to show you a better way to do that in a moment. Okay. Now, the other thing is edge cases. So we've just tested some regular sort of things that we'd expect to throw at this particular function, right? But what we need to also do is test some edge cases. So edge cases are those particular test cases that exist at the boundary of our data range that we wish to test, but are still actually valid test data, right? So test it returns, I'm just shortening some of this, returns expected values for edge cases. Edge case, oops, where crew is an empty string, okay? So what we're going to do here is put in the actual result is equal to calculate crew size like this, right? So we could null strings, this is an edge case, but it is valid data. Assert actual result, excuse me, is none. Okay, so it should return nothing in this particular case. All right. Right, so this is the way. So if we just test that, we can see how the code is supposed to operate. It returns nothing. It doesn't even return 0. It's just returning none. Now, whether that's correct behavior or not is another one of those discussions we can have with our colleague, because it could be that we'd expect it to say 0 and not come back with none. Okay, but in this particular case, we'll assume that's correct for the moment, and this tests will assume this is correct behavior, and this test is correct. Okay. So once we've done that, we can then, I'm going to exit out of the terminal in this case, and I'm going to run PyTest again. And fingers crossed, we should see we get those 2 additional tests also pass it. Okay, so if you've managed to get to that point, run your tests, and you see 3 glorious dots there, feel free to give us a green tick. Otherwise, let us know how it's going and if we can help. If you'd like a bit more explanation about anything in particular, feel free to ask questions or put any errors into the chat that you might be seeing. Oh, I see a hand. Yes, Jen, what's your question?
I think I have a small question. How come at some cases we use expected result and then assert that the actual result matches expected values, and in other cases we just go with a simple assert statement?
Good question. This is, as we saw yesterday, this is a code styling question, really, and it's to do with consistency. So for this particular exercise, what we've done is we've tried to make it explicit what's going where, basically. So we've made it so that we're using variables that are very, very clearly defined with the actual and expected values, just to avoid any confusion, and then testing the equality of that. That's a code styling choice for our tests. Right. And with more complicated tests, sometimes that's a really good idea because these variables may need to be constructed in a way that's complex. And that's not something we could do on a single line. In this particular case, I agree that it's probably worth visiting because if we go up here, we're using this style to do it. And later on, we're not doing that. The style is inconsistent. So the other thing we could do is, yes, we could rewrite these to use this format. Okay. In this particular case, that's probably a good idea because then we'd be consistent in how we're writing our tests. And then if our tests got more complicated and did require a lot more manipulation of this particular variable in order to get that variable into the right state, then we could use this method where needed. So yes, good question. Consistency should apply to our tests as it does to our code. Yeah.
Thank you.
No problem. Right. I think we're probably just about there. So if you've managed to get to this point, that's great. Again, if you haven't, please let us know and we'll see what we can do to sort out your problem. So looking at our test functions, you may notice they do not follow the don't repeat yourself or dry principle. I'm just going to put this into the chat. All right, a link to this if you're interested. So basically, when we're writing code, we should avoid code duplication. And you will notice that with this particular function here, we're using exactly the same code to do this particular test. And as we've said, this test in a real setting could be a lot more complicated, right? And what we would want to do is avoid copying and pasting that particular setup code for every single test case that needs to run that code, okay? So this could result in maintenance problems where we change the way we're setting up that test in one function, but don't do it in another. You know, very similar to how we write our normal code. In test code, the same concerns apply, right? So if all we're doing is we're doing the same code, but all we're doing is we're changing the values which we're testing, right? And the result that we are testing it against. That's all we're doing, right? So to avoid such repetitions in our test code, we can use an approach called test parameterization. Okay, and what we'll do is we'll do this and then we'll go to a break. Okay, so what test parameterization does, it allows us to apply our test function to a list of input and expected output pairs without the need for repetition. So what we can do is we can rewrite this test calculate crew size function to use parameterization so we can see how that works. So let's do that now and rewrite it. Okay, now it uses PyTest's parameterization to do that. Okay, and the way we do that is we use something called a decorator, right? Now, if you've encountered a decorator before in Python, feel free to give me an uptick. If you haven't, please feel free to give us a red cross just so I know if decorators in Pythons are things that you've generally come into contact with. Okay, so one of you has, but most of you haven't. So okay, so a Python decorator is a way of modifying how a particular Python function or class works. Okay, so what I'll do is I'll write this out, and then what we'll do is we'll then go through what this particular decorator does. Okay, so what we're going to do is we're going to give PyTest mark parameterized decorator input value and input underscore value and expected result. Right. Oops. Make sure I get this right. And then, right, so I need to close that. So, and we're going to change this function to have two new parameters, input value and expected result, like that. Okay. And what we're doing is we're going to tell the parameterized decorator that these are the two arguments that we need to change each time when we call this function with a different data. And then what we do is we give it the different data we want to call it each time, right? So in this case, as you may recall, we had Valentina Tereshkova with that semicolon, and the expected result we want is 1. Okay, we pass that in as a Python tuple. That's a bit annoying. And now we'll give the other one, which is Judith Resnick and Sally Ride. Okay, and the expected result we expect from that is 2. Oops. So what we end up with is something that looks like this. Okay, and I noticed that I need to put these in as a list. Python list, like that. So what we're doing is we're basically telling PyTest that we wish to parameterize this particular function, right, over these particular input values to the function, which basically means we're going to call this particular function for as many times as we give it input data. And then what we do is we pass the parameterized function effectively sets of each of the input data we wish to pass to it. Okay, and in this case, it's Valentina Tereshkova and 1. So in this case, input value will be equal to Valentina Tereshkova, and expected result will be equal to 1. And then we want to pass this in instead as well, following that. So it's then going to call the function with Judith Resnick Sally Ride as the input value, and 2 is the expected result. Okay, now what we can do now is we can just change this particular piece of code here to use those values instead. Okay, so the input value which we pass to the function needs to go to calculate crew size, and the expected results, well, we already have that, so we can just do this, right? So instead of having this code that was duplicated, what we have now is this parameterized test function where we're putting in arguments to our function, and in each case, every time it's called, different data will be fed to it, right? Either this or this, okay? And then effectively, the same code is basically going to be called as we had before, right? So this decorator then is modifying how this particular test function will be called and stating how we want that to happen, okay? So does that seem clear? Decorators can be a bit of a mind bender, but yes, feel free to ask. Are there any questions about if that's unclear or if you need that explained any further?
Can we just request these to be pasted on the?
Yes, I certainly can. It's a little bit tricky, I agree. So I'm going to put that directly into the chat. There we go. So, okay, I'll put that in as we normally do using backticks. Okay, yes, it's a little bit tricky, isn't it, Phoebe? I totally agree. So yes, so basically what we had before was a function that looked like this. Okay, and what we did is we tested each of the things we wanted to test by just expanding the contents of the function to do each of those tests, right? But that's duplicating our code. right? Which isn't particularly good, particularly if the way we're running these tests in each case is more complicated, okay? Because we're duplicating our code. As we know, if we duplicate our code, we can run into errors if we decide to alter it in one place but not in another, right? So what we do is we use a technique called parameterization using a decorator for PyTest, which changes the way in which this test is run, okay? So as opposed to running this function once, it's going to run as many times as we want it to for each of the data that we give it, right? So to do that, we need to change the function to pass in the input value that we expect, that we want to test, and the expected value that we want to test against. And what we do then is we basically mirror that here by saying these are the two arguments that we wish to parameterize for this particular function. And this is the data we are going to call the function with each time, okay? So it's kind of like having two separate functions with the same code, right? But in this case, what we've done is we've compressed those two functions into one, right? So that the code that we're using each time is exactly the same. It's not duplicated. I hope that's clear. It can be a bit tricky. I don't know if that helps at all.
So question, just so basically the parameterization has it has a data that will be used as a basis for that testing, the testing. Is that correct?
That's it. That's it
Way of
exactly.
thinking. Okay.
That's it exactly. So effectively, we're basically giving it the data that's going to be passed into that function as many times as you wish to supply it. We could add more in here, and that would mean that if we had another line in here, that means this particular test function would be called another time. Yeah. So yes, I hope that answers your question. Right. So I see that Andrea has a hand as well. Stephen,
Can I ask? Yes. Is this decoration specific to the next function, or can it be used for other? Are they linked somehow?
That's an excellent question. So yes, in this particular case, it's just for this particular function. So we're just changing how this particular function will be called, if that makes sense. We're only changing the behavior for this particular test function. So it's not going to change how this one will be called, only this one. You can think of it as like instead of having one entry, PyTest will see two, right? And call that function twice with each of these values in turn.
Yeah, but I mean, can we use input value and expect result later in this same file, or is the decorator something that is really linked to what is happening just after?
It's right, yes, I see what you mean. So yes, it's only linked to this particular function. Okay, so a decorator applies to either a function or a class. And in this case, we're only applying it to this function. So that's an important distinction. So where this is defined, it will dictate what it will apply to. And since it occurs, the definition occurs just before this particular function, that's the function it will apply. So what we could do is we could write another one of these just above test, calculate crew size edge cases, right? And we could parameterize that as well if we had more edge cases that we wish to test. Okay, so we could parameterize that differently, but use a different set of input data, if that makes sense. So yes, we can use parameterization whenever we want to change how we define those tests. But in this case, yes, it's only applying to that particular test case. Does that answer your question?
Yes, thank you.
Okay, brilliant. Yes, it can be a little tricky to wrap your head around, and it's a bit of a leap, I have to say. So yes, we might want to consider covering decorators perhaps before we get to parameterization, because that's a bit of a mind bender. But yeah, effectively, it just means that we can write tests using one piece of code and feed in different data each time to run the test. Okay, so now if we've done that and we've saved the file, hopefully we haven't got any errors. If we run that again, we should see that we now get those tests running. Okay.
Can I just quickly reiterate what Steve said, that the position of the decorator is really important, and it only applies to the function or class straight underneath it. And I think if you put a blank line between the decorator and the function, I think it will cause an error, or won't run as expected, I believe. I think I've been caught out by this.
Yeah, I think it still works.
Will still work, okay.
It still, but yeah, it will only apply to the next following function. Yes, that's correct. Yeah.
Okay, so yeah, that's good to know that it will still work. And
Yeah.
also another thing I wanted to say is that this is not the only decorator. This is a bit more advanced Python or intermediate Python. So there are other decorators that can be used, but this particular one is useful for testing.
Precisely. Decorators is a feature you can use in Python if and when you think it is useful. So here's a link to a little bit more information on what decorators are. And gives you a little bit of a tutorial there on what they do and how they operate. But effectively, it's a way to change how the behavior of a function when it's called. Okay. So it's like, yeah, it's basically the way of, you can basically change the behavior of a function by doing something before you call it and after you call it. And that's basically the way a decorator works. Okay, right. Okay, so a little bit of advanced Python there. I hope that's of use and hopefully not too confusing. But effectively, it should do what it did before. Okay, but effectively, it's just doing it in a way that's a little bit more maintainable. So it means we only need to change this code here. And for more complicated tests, it gets really useful. Okay, so right. So as you can see, it's short, it's readable, and hopefully it's a lot easier to maintain. And if we want to add more, right, we can just keep adding more data here, right, and changing that data obviously each time for different test cases. And it means that we just add a new line each time as opposed to a new function each time. But the behavior is the same, right? So it's a lot more maintainable and easier to change the tests. Right, so we've so far only written tests for two individual functions, text duration and calculate crew size. Okay, and one thing we're going to come onto after the break is checking how much of the proportion of our code is run by our given test suite. Okay, so how much code coverage do our tests cover? How much of our code are we actually testing? And is it enough? Okay, so what we'll do is we'll go for a break for 15 minutes now. And so I think what we'll do is we'll come back at 6 minutes past 12. Thank you, Alex. So, okay, right. Feel free to post any questions or ask any questions. Post them into the chat or ask them now. That's fine. Otherwise, I'll see you back at 12:06. Okay.
Hi, Steve. Sorry, I have a very small question.
Sure.
Remember when you said that PyTest should only iterate over anything within the test function? But I didn't delete the original test file that we wrote in the spacewalk
Yes.
directory, and it does go over it every time.
This is correct, yes. So what PyTest is doing is it's finding every single file that it can in the current directory and in the tests directory that starts with test underscore, right? So it's running those tests as well, I suspect. So I noted that when I was testing this yesterday. So yeah, to be absolutely clear, if you've got your test underscore EVA analysis.py file sitting in your tests directory, feel free to go ahead and delete the test underscore code.py file. You won't need that anymore.
Oh, yes, thank you.
No problem at all. Good question. Yes, PyTest is a bit hungry in terms of what it looks for. Right, see you back at 12:06. Right, welcome back, everybody. So I'm going to put a comment into the chat, which is I've returned from the break. So if you have indeed returned from the break, feel free to give that a thumbs up just so we know who's here and ready to go. Okay, for those of you that have just come back from the break, feel free to give us a thumbs up on the comment in the chat, which is I have returned from the break. So give it another minute or so, and then we'll continue. Right. Okay. So I think we're probably just about there. So I think what we'll do is we'll make a restart on where we were, from where we were. So you may remember before the break, we were talking very briefly about code coverage. Okay. So we've only written tests for two individual functions, text to duration and calculate cruise size. And we can quantify the proportion of our code base that is actually being tested by a given test suite using a metric called code coverage. And if you go to the Code EMD doc, you'll see I've given a quick definition of that in there. And so this code or line coverage of our tests is essentially equal to the number of code lines executed by tests divided by the total number of executable code lines. And then we multiply that resultant figure by 100 and we get a percentage. How much of our code lines are actually being tested? Okay. Okay. So, and we can determine this by using a tool called an approach called code coverage, right? So the way that we do that is we use a library that you may recall we installed earlier, which is pytest-cov, okay? And I said we would refer to it later, and here we are. So what we can do is we can invoke pytest as we did before, but I'm going to ask it now to give us code coverage metrics as well. So I'm going to put a space and then use two hyphens followed by COV, short for coverage. Then I'm going to press return in the terminal, right? So invoking it just as I did before, but adding hyphen hyphen COV, press return. And then we get something that tells us exactly what we saw before, but also some additional information about the code coverage, okay? And we can see here that in this particular case, you can see that our code, right, we have our tests here. Now, we're not interested in our tests particularly, although we can see that the code coverage is 100% on the tests because every single line of our tests are actually being executed. But more importantly, in our test, in our actual code base, we can see there are 58 executable statements and 39 that have been missed. Okay, so we can see we have a coverage of 33%. Okay, all right. So that means that our code coverage for our test for our actual code is 33%. Okay, so 33% of the executable lines in this particular file are actually getting tested, okay, by our tests. Right. So this is kind of handy. It's nice as a summary, but it'd be nice to have some more information. And we can get an in-depth report by doing exactly the same. So I just go use the up arrow there on my keyboard and tell the code coverage plugin for PyTest that what we want to do is you want to have an HTML report. Okay. So I do hyphen hyphen COV hyphen report equals HTML. Okay. And this will give us an in-depth report. Okay. If I press return on that, it goes ahead and it then creates some HTML documentation for that code coverage report in a directory called HTML COV. Okay. And what I do is I can open that with a file reader somewhere. It doesn't matter. You can open this any way you like. I'm just going to search for it using my file viewer, if I can remember where it is. It should be in my home directory. I think there's a little bit more. There it is, spacewalks. And then within spacewalks, there's this new HTML COV directory. Double click on that. And then what I do is I double click on index.html, and that should bring it up in a browser for me, right? And what I do get is something that looks a bit like this, right? So the interesting thing here is it shows us a table showing the proportion of lines in each function. Well, it gives us an overall table of what we've seen before, but if we click on an individual file, it gives us the proportion of lines in each function that are currently tested and an annotated copy of our code where untested lines are highlighted in red. And this is particularly interesting because it tells us which lines are being tested and which ones are not, right? So the red ones are not being tested, okay? So we can see here that we know that we've got tests for text to duration, and we can see that all 3 lines there in our code function are being tested. We also know that we're testing calculate crew size, which is good. And interestingly, we can see that both branches of this if statement are also being tested. You may recall one of our tests was an edge case, right? And that edge case tested for what happens when we pass it an empty string. It just so happens that that edge case is testing that particular branch in the code, right? And also, make that a bit bigger for you, we can see that this one's also being tested as well, okay? So this is kind of handy as a kind of a way of determining to what extent our code is actually being tested by our tests, right? Now, it would be ideal for all lines in our code base to be exercised by at least one test. But often we lack the time and resources to test every single line of our code as we could, right? So we could, for example, write a test suite with hundreds of test functions that test absolutely everything, but there's often no way we could do that in practice. So there's some things we can do that we don't need to test, right? We don't need to test Python's built-in functions or functions imported from well-known and well-tested libraries like Pandas or NumPy. And what we should do is try and focus on the parts of our code that carry the greatest reputational risk for ourselves, i.e. that could affect the accuracy of reported results. So if we're writing code that is going to generate results that is going to end up in a publication, it's probably an idea to focus on writing tests that are actually associated with the generation of that particular data, right? Those critical functions that do that actual analysis that create that data is something we should probably focus our attention on writing tests for. So whilst having the aspiration of having 100% code coverage is really good, it's not always going to be possible in practice. And with real code bases, it will be impossible in practice. So we need to focus our attentions on where we should be testing code. So in short, a test coverage of less than 100% indicates that more testing may be helpful. Test coverage of 100% does not mean our code is bug-free, okay? Because again, the tests may be insufficient to determine all the bugs that are in our code, even if every single branch in our code is being tested, every single line in our code is being tested. It may not be enough, okay? So testing is not a panacea for determining every single problem we have with our code, but it is a very useful mechanism to do that, all right? Right, so what we should do now, of course, as we've been making changes to our code, fixing a bug for one, and also adding in a test suite, we should be adding this to version control, all right? So that's what we're going to do now, right? So what I'd like you to do is go back to your bash terminal, right, and do a git status, and you should find there's a few other things here that we have that we probably should consider adding, okay? What I'd like you to do is to add to git add EVA data analysis. Remember, we fixed that bug, right? And added, I think, some additional analysis functions. So what I'd like you to do is to do git add on that file and fix bug, other additions. Actually, yes, other additions to the file, something like that, right? So that makes sure that the fix has now been put into version control. Now, I'd also like you to add the tests directory. So that includes our tests file that we've been working on in this session. So git add tests. So we give it the directory there, and then a git commit with the message add test suite, return. Okay. Now, the other thing that you may have noticed is that what we've also done is we've included some changes to our environment, right? So we've added PyTest and PyTest Cov, okay, as two additional libraries that we're now using. So if you do Python 3 -m pip freeze, which will give us a list of our current libraries that we're using in the Python environment, in the virtual environment, and then output that to requirements.txt. So this is something we've done before. We're just going to do it again to refresh those requirements for the packages that are needed. Okay, like that. And then obviously the requirements themselves have changed. So we need to add that into version control like this. Just make sure I don't go off the top there so you can still see what I'm doing. And then we're going to push those changes up to our remote repository by doing git push origin and main. All right. So I'll just make sure that's all in there. So, right. Okay. So these are the commands you'll need to type in from this point onwards. Okay. So once you've done that, you give us a green tick. That'd be great just to check that you're up to speed. Otherwise, if you have any problems or questions, feel free to let us know. Jen, yes.
Hello, sorry. So I actually had an issue with the previous step with the PyTest Cov report. So for some reason, it's giving me a module not found error, even though when I go into the help of PyTest Cov, I can see the Cov report listed there.
Interesting. Could you paste the error into the chat?
Okay.
Just so I get the full context. That's interesting.
And which directory are you running the command from? Are you running it from the root?
Spacewalks.
Okay.
Okay. PyTest or Oh, interesting. So I didn't get the error this time. However,
Right.
when I do an ls, I also do not see an HTML folder.
You don't see the HTML COV folder, is that correct?
No. So okay, I'm just gonna copy and paste everything I've done.
There's also an interesting question here in the chat, which is, what do we do with these dot coverage and PyCache folders? Yes, you should not be ideally committing those. I believe we've covered git ignore files. So very quickly, what you can do is you can add in PyCache and dot coverage into your git ignore file, right? So sorry, that should be here. So what I've done is I'll just leave that here for those. I've just added those two lines into my dot git ignore, so they shouldn't be committed. But yes, that's a good point. We shouldn't be adding those to our repository. So thank you, Jen. Let's have a look at that error. Okay. I think I know what it is. Yes. So, yeah, it's a bit of a gotcha, this one. So when you're doing this, you also need to include hyphen hyphen COV separately beforehand. So I think what happens otherwise is you're passing in a parameter to the Cov plugin to PyTest, but not actually invoking the Cov plugin. So in order to get code coverage to work, you need to have hyphen hyphen COV in there as well as hyphen hyphen COV minus report, if that makes sense.
Thanks. Yeah, I missed that.
No problem at all.
Hi, Steve. I also had,
Yes.
I think I missed a step because I got lost. Can I just paste what I get?
Yeah, please do. That's fine.
It's very long though, sorry.
That's okay. We'll make do.
Let me just look for it. Oh dear. Can I just include the upper part? I think that's better.
Yeah, if it's particularly unwieldy, you might want to put it into the CodeMD shared doc. That might be a little easier to read.
Yeah. That's. No, sorry, I'm pasting it in text. All right, it's over 100. It's over 1,000.
Oh my word. Okay, I don't know if that's going to be easily passable. Okay, tuple object is not callable. Okay, so I think the key there is for us to see your test EVA analysis.py function where you're using the parameterization. So you may remember it looks a bit like this. So if you copy and paste that particular function with the PyTest Smart parameterized within it into the CodeMD shared document, I suspect we'll be able to spot the problem. I think I know what it is.
Shall I just paste? Is it in our shared document?
Yes, please. Yes, I think that'll be easier to read. That'd be great. Thank you.
Sorry, you mean I copy that?
So, copy the function with the decorator, this bit that I'm highlighting here on the screen, where it is in your own code, of course. Copy that into the CodeMD doc.
Oh, there. Where is the? Finally found it. Sorry. Sorry, you mean I copy the code from my.
Right. Okay. So, sorry, 1 second. So we have a number of queries. I'm just going to add them. So the git ignore file. I'm putting this into the CodeMD doc. Your git ignore file should include what I've just put there into the CodeMD doc. I hope that's helpful for you, Andrea. It has been going a bit fast. So your
Yes,
CodeMD
thank
should look
you.
like that. Okay, no problem. So Stephen, yes. So in your test EVA analysis.py file, if you could copy this particular function where I've highlighted it and put that into brilliant. I see you've done it. That's good. Right. Okay. So
Mistake.
It makes it easier. Stephen can share his screen as well. I made him co-host if it helps.
Can I
I
share
don't
my
know.
screen?
So I think what I'll try and do first is just see if I can get that to work here in my particular file and see if we have an error there. That might be the quickest way.
I have a suggestion. I don't know if this will solve it, but it looks like in the command that was pasted in the chat, there was only one dash before cov. So just make sure that when you've got like Python -m PyTest and then double dash.
Well spotted, Billy. That's it. That'll be the problem. So yes, that's the issue you're seeing there. I suspect. So the tuple object is not callable. Does seem to be a bit of a red herring. I did test your code, your function in my own, and it did seem to work. So I think Philly's probably got it there. So yes.
So it should be Python 3 -m PyTest _cov.
Yes, that's correct.
Let me try again.
Right. Okay. So I think I'll leave you to one of our helpers to help you with continuing with that. Okay. So yes, if Philly or Alex could help out there, that would be great. But if it works, by all means, let us know. So if you have got to the point where you've been able to run the code coverage, if you give us a green tick, that would be great. Just so I can just check where people generally are. Okay.
It doesn't work. So it doesn't work. Sorry. I don't know why.
Okay. All right. So yes, I'll leave you with the capable hands of Philly and Alex to help you investigate further if they're able to.
Yeah.
Okay. Right. But what we're going to do now is we're going to move on to how we can execute our tests in VS Code. Okay. Now, VS Code supports the running of unit tests within its IDE, including tests written in PyTest. So, in order to enable the support, we can configure which kind of tests we wish to run from within VS Code. Right. So one way we can do that is by clicking on the test beaker icon in VS Code, which looks like this. You'll see down here I have this little test beaker. If I click on that, I see a little big pop-up, big button that says configure Python tests. Okay. Now, if you go ahead and click on that, all right, it'll then hopefully give you two options, unit test or PyTest. Now we're actually using PyTest, so we should select PyTest. Okay. And then what it'll ask for is the location of your directory. Okay. And if you select the directory, the tests directory, that should be it. Okay. And hopefully you should then find that it comes up with this. So another way to do it is to use the command palette. So you can do on Windows, it's Control-Shift-P. On Mac or Linux, it will be the Mac key or Windows key with Shift and P, like this. And then what we can do is we can type in Python configure tests. And you'll see that there's an option there that's popping up, Python configure tests. Then press return and select Python there instead. And also the location of our tests directory, which is tests. Okay. So if you've managed to... Sorry, go on.
Can you repeat that? So we select Control-Shift-P or configure Python tests.
Yes. So if you're on Windows, it's Control-Shift-P. On Mac or Linux, it's the Mac or Windows key. You do okay. So you do Control-Shift-P or the Windows Mac key Shift-P, and then type Python : configure tests, and you should see it pop up here.
No.
No.
I'll try
Okay. So
again.
the key here is not to put it into this box here. Okay. But the key is to make sure you've run the command palette. The other way to do it is you can run the command palette a different way. I think I haven't done it this way for a while.
So I couldn't also follow that beaker. Can I go through that path too? So the
Yes,
first one that you showed.
Yes, if you click on the beaker, you should see a big blue button that says configure.
Configure,
test.
yeah.
If you click on that, then it will say, give you a choice at the top of either unit test or PyTest. Select PyTest.
Yes, so it says unit test.
And PyTest, is that right, just below it?
No. Yeah, there is a PyTest framework. Yeah, okay,
yes.
Got it.
Brilliant. Click on that, and then it will come up with a list of files. If you click on the tests entry, which should be near the top, that should set. You're basically telling it where your tests are located, essentially.
Yeah, I don't see that, but I can. Should I give the path then? Type the path or something.
Okay, so I think right. So you don't need to type the path. It should automatically be there. So what I did is I selected PyTest. If you look at my screen,
yeah,
and then it gives us a list of directories, and one of those is the tests directory.
Yeah.
And you select.
Yeah. Okay, I'll try again. Sorry about that.
That's okay. It's no problem. And then if you select the tests directory, that should be it.
So can I reset it, because now it seems to. So is there any way, because I did something and it has that the blue buttons have vanished?
Okay. All right. So the other way to do it is to use the command palette. So are you on Windows?
No, I'm on Mac.
Mac. Okay. So if you press the Mac key, the Shift key, and the P key all at once, you should find you end up with this.
Yeah.
Something that looks a bit like this. Okay, so now if you type in Python : configure tests, you should find that you get this Python configure tests entry just here. Can you see that on my screen?
Yeah. Yes.
Brilliant. So if you click on that, it'll then give you a choice of which test framework to enable. And one of those should be PyTest,
PyTest. Okay.
just beneath it. Yeah?
Okay. Yeah.
Yeah. So if you click on that, and then it should give you a choice to select the directory containing the tests, right?
Okay.
And there
Yeah.
should be an entry that says tests. Does that look good?
Right. Yeah. That's great. Thank you.
Brilliant. Awesome. Okay, so that should be good. Hopefully that's got that sorted for you. Andreas, yes, I see you have a hand there.
Yes, thank you. So my issue is that when I look for the directories, there's only spacewalks. There's only one directory, which is spacewalks. There's no tests or whatever, because I think I have like an external folder that I shouldn't have, but
I see. So, okay. So yeah, so what you could do, I don't know if it allows you to travel directories. What you could do is try reopening VS Code from within the spacewalks directory. That makes sense?
from the terminal.
You can do it from the terminal. Are you, which machine are you on?
I'm in Windows and
Windows.
yeah.
Right. It's probably easy if you run VS Code again. So I'll show you how to do that. So if you click on, if you just run VS Code from your start menu, I'll do it a slightly different way. Right. And then if you've got VS Code looking like this, if you just start it from the
It opens automatically the folder where we were.
No problem, no problem. Okay, so what I'll do is I'll open that. Right. So what you can do is you can then go to File, Open Folder, I think it is. It's either
Yeah.
Open or Open Folder. Click on Open Folder. Now, if you then traverse to the location of the Spacewalks folder, right? Mine's in a slightly different place. I think mine's just here. And then click Open once you've selected the Spacewalks folder. Hopefully, it should open in the right location. Fingers crossed.
Yes, but this one is not linked to my Git, which is a problem, right?
It shouldn't matter if within your Spacewalks directory, yeah, it shouldn't matter. So if you run a terminal from within VS Code by doing terminal new terminal, right, you should find you're inside the Spacewalks directory. Is that correct?
Oh, okay, yes, I think so.
Brilliant.
Yes, okay.
So if you do git status and press return, does it then give you a meaningful result?
Yes, I think so. Okay, so
Good.
now from here, I should be able to do the tests.
Yes,
thing.
fingers crossed.
Yes. Okay, thank you.
Good. Yep. Select PyTest and then the test directory. Hopefully.
Well, I got an error saying that PyTest selected but not installed.
Okay. So I suspect it's to do with where you've put your virtual environment. If you put your virtual environment outside of the Spacewalks directory, that's probably going to be an issue. I suspect that it's having problems identifying where that is because it's sitting in a location above your current directory. So what you could do is recreate your virtual environment within the Spacewalks directory, and then it should be picked up. But remember that you'll need to install matplotlib, NumPy, PyTest, and PyTest-cov as well, as we did earlier.
Okay.
So perhaps one of the help is go on.
Yeah, just a small question. Do I have to delete the other environment before creating a new one?
No, not necessarily. You can leave it there. If it's not active at the moment, then you can just leave it. So just create another one.
Okay,
now.
Thank you.
No problem.
Okay.
Quick question in the chat as well. to have the steps specified in the shared document, if possible.
Oh,
Yeah,
yeah,
sorry
yeah.
about that. So
That's okay. Sorry, go on. Yes, please.
hello?
Hello.
Am
Yeah,
I
sorry.
audible?
What's your question?
Yes. Yeah, so I think Alex was asking about the chat, which was not clear that I just mentioned regarding the steps.
Sorry, the steps for what?
The steps for going into the environment that I was just having a problem with, I couldn't solve it. So I was just wondering if, and I forgot which ones should I now select?
Oh, okay. Do you mean for configuring PyTest?
For configuring PyTest, thank you. Yes, please. Yeah.
Okay. Right. So, okay. So,
We need to make
right.
sure that someone writes this down.
We do. So, Alex, if you could write this down whilst I go through it, that's probably the way to do it. Okay. So you've already gone through it once. So using the beaker approach probably won't work. Okay. So what you need to do is you need to open the command palette. So you're on Windows or no, Mac. Is that right? You're on Mac. So it's the Mac key, Shift and P. Yeah, and you should get something that looks like this. You've already executed this before, so you should see Python : configure tests near the top. Do you see that? Sorry, you're muted.
No, I'll try again. I was not seeing it anymore, actually.
Okay, all right. So you can type in Python
Yeah.
configure tests. Yeah.
So I can Python configure tests. Yeah, it has come up now. So I select that.
You select that, and then you should find you have two choices: unit test and PyTest.
Yeah.
Okay. So if you select PyTest, tell me when you've done.
Yeah. Selected PyTest.
Great. Now you should have a list of directories that pops up. And one of those directories should be tests.
No, I just, maybe because I opened VS Code from my root directory. And that is why perhaps I don't see the tests.
Okay, that's going to be the problem. So what you'll need to do is you'll need to reopen VS Code from within the Spacewalks directory. Okay.
Yeah.
So as we had the issue earlier, you can do that by going to File, Open Folder, right, from within VS Code.
Okay.
Yeah, File, Open Folder. Okay. Now, if you navigate to where your Spacewalks directory is, in my case, it's in my root directory, and then I just click Open, right? But yours might be somewhere else. Okay.
Yeah. So I navigate to Spacewalks and then say Open.
Correct. Yes, that's right. That's it exactly. Yes.
Okay. And now if I do the same thing, I do Command Shift P, I do Python configure tests and select PyTest. And now I can see the tests folder. So I have selected that.
That's great. Awesome.
Okay.
I'm so happy for you. Okay.
Thanks a lot.
Just out of curiosity, how did you open where were you located? You did
in the root directory of the file system.
Okay, so you opened the root directory in VS Code. Oh, that's a very good spot.
Yeah.
I don't think I would be able to figure that one out.
She spotted it, so that was good. It was a good self-diagnosis there. Very good. So so that's good. So no problem at all. So if we've got to that point, what we can do now is we can do some magic, hopefully, right? So if we go to the test explorer here, right, you should see that we have this appear, right? And this is telling us that, hey, I've identified some tests, and you can drill down on those and see what those are, right? If you click on the beaker, you should see this here. You can drill down and see that each of these tests have been picked up from our tests directory, fingers crossed. So if you've been able to see that, if you could give me a green tick, then that would be awesome. Okay, all right. So if you got to that point, you can now run the test from here if you wish by clicking on the play button, right? And this is pretty neat because hopefully they all work. What it does is it goes away and runs the tests, and you can see on the test results here, right? So we're not in the terminal here. It's opened up a new window, a new pane at the bottom called test results, and it's showing us the test results have been all successfully run. So if you've been able to do that, give us a green tick. Okay. Okay, good. A few of you still with us. That's good. Right. The other way you can run tests is by going to your test EVA analysis.python within VS Code, and you can look for the test function name. In this case, it's either going to be where it defines the function or where it starts with the decorator for PyTest parameterize. Then you can click on this button, and it will go and rerun the test, that specific test for you. So you can run explicit tests if you wish, or you can run the entire test suite, which is kind of useful. So if you know that you've made a change and you want to test a particular function in your code again, you don't want to run the entire test suite, maybe it takes too long, you can specify that by selecting specific tests. So here we go. We can see that it's picked up the parameterization of these tests here. We can run for Valentina Tereshkova. We can see it works. We can run for Judith. We can see it works. And you can see that there's results being displayed here as well. And it shows us there's older results. Test runs were happened before. So it even gives us a complete history of all of our test runs, okay, which is actually really handy, okay? Right, okay, so I think we've got enough time to briefly cover the next bits. I think that's probably worth attacking. But before we do, what questions or problems do people still have before we move on? Okay, right. Okay, I think we're in a pretty good state. So what we're going to do is we're going to move on to something which is called continuous integration, and we're just going to try and see if we can get through that to the end. So I'm just going to see if I can bring up my slides. Okay, so I just need to reset that. No, that's not right. Okay, so we've seen how automation of testing can help us. So we can build on this concept of automation by taking it even further with something called continuous integration. So continuous integration basically is the practice of regularly integrating code changes into a shared code repository. And it automatically enables us to run tasks and do key checks each time this happens. So every time the changes are merged into our code base, we can do things like run tests and things like that, our unit tests that we've been developing. Now, software development typically progresses in incremental steps, requires a significant time investment. It's not realistic to expect a complete feature-rich application to emerge out of nowhere. It's going to take time, and it's going to take a lot of steps for us to get to that point. And continuous integration is based on the principle that software development is this incremental process. So as we're continually making changes to our code base, what we're doing is we're making sure that we're checking our codes is correct before we continue to do more incremental updates. And what continuous integration does is it basically takes advantage of this kind of process, right? So every time that we're actually making changes, we're checking it with our code base, we're making sure the integration of these changes is working with our entire code base. So these changes are working with all the other changes that have already been made. And as we've seen, unit testing can help here. So the kinds of things that we can do, the tasks that we can automate using continuous integration are things like compiling code, running a test suite, verifying the code adheres to project team or language style guidelines. So as Philly talked about yesterday, there was linting. You may recall we could use code linters that we can run that will effectively run over our code and either format it for us or give us an idea of what the issues are with code style. In that way, we could do this in an automated way using CI, or we could use CI even to do things like building documentation, such as API pages extracted from code doc strings, or other documentation written in Markdown or something. Okay, so there's a lot of things we could do in an automated way using continuous integration. Okay. So there's a wide range of continuous integration focused workflow services and different tools you can use to support various aspects of continuous integration. And many of these provide access via a web-based interface, and they're out there, and a lot of them are free. Okay, one of those which we're going to look at in a moment is GitHub Actions, but there are others as well. There's Travis Continuous Integration. I think Circle CI is still around, and TeamCity. And basically, they provide infrastructure that enables this automated set of tasks to run when things happen to your code, right? And the code will run on their servers in the cloud somewhere, right? But there are others as well. There's GitLab CI, which is great if you want to deploy it on your own system, Jenkins and BuildBot. So there are lots of different types of CI technologies that you can make use of. And if you learn the skills in one of these particular technologies, you can transfer these skills to another, okay? So they tend to be readily transferable skills. And beyond that, there's something called, which I'll very briefly touch on, called continuous deployment and delivery. And this is basically where you couple continuous integration with continuous deployment. So with continuous deployment, this is where it could be automatically deploying updates to test or production systems. Or it could be a web application you're deploying every time a new change passes the CI pipeline. So you run your CI tests to check your code's working correctly. And then what happens is your code is then deployed automatically as part of this pipeline. So it's continuously providing something that is on offer and can be used. Okay, all right. So what we're going to do is we're going to look at a CI workflow. We don't have a terrific amount of time, so we're going to go through this a little bit quickly. We're going to see how we can define a workflow to automatically run our tests when we push code to our repository. And what's going to happen is this workflow is going to run those automated tests using something called GitHub Actions, and all of that is going to happen in the cloud effectively on GitHub's servers. Okay. All right. So let's get rid of this. And what I'm going to do is I'm going to shortcut this a little bit for time. Right. Okay, so what I'd like you to do is I'd like you to create a new set of directories, right? So we're going to do that by using the make dir command in bash to create a .github directory, and within that, another directory called workflows, okay? So if we do make dir with a -p argument, it'll create the .github directory and also the workflows directory within that .github directory like this, okay? So make sure, again, you're in your spacewalks directory. So if you've managed to get to that point, if you could give us a green tick. So you should find that if you do ls-a, you should find you have a GitHub directory just here, okay? Right. So now what we need to do is we need to create our workflow, okay? So if you go back to the File Explorer in VS Code and then go to the GitHub directory and the Workflows directory, what you can do is, making sure you have the workflows selected, is click on the new file icon and then give the file a name, and we're going to call it main.yml. Okay, and I'm going to press return there. And it'll come up with a blank file that is now hopefully sitting in .github/workflows. Okay, so on the command line, I should be able to do ls.github/workflows, and it comes up with main.yaml. Okay, now it would be great to know from all of you if you've ever heard of YML or ever worked with YML before. So if you have, give us a green tick, or if you haven't, feel free to please give us a red cross, just to let us know. Okay, all right, so it's half and half. Okay, right, so I'm going to show you basically how to build a workflow from scratch, and we'll go through what the formatting of YAML is and how it works as we do that. Now, YAML basically is built on being able to specify key value pairs. So what you do is you specify something like this, and we'll start defining our workflow as we go. So what we're going to do is we're going to give our workflow a name, and I'm going to give it a name of CI, right? So I specify what the field is. In this case, it's name with a colon, and then specify CI, okay? And then I'm going to say I want this workflow to run when things are pushed to my repository, right? So on is basically saying when this workflow is going to run, okay? So when we've done that, we then need to specify which continuous integration jobs we're going to run, all right? And we do that by specifying a list of jobs. And similar to Python, we can specify a number of items by using indentation, right? So we can specify a number of continuous integration jobs that we wish to run. And one of those is going to be build and test. And this is the only job we're going to define, right? So we put that in here, again, making sure we have this colon on the end. And as part of build and test, we need to specify where it's going to run, okay? And we're going to say it's going to run on the latest version of Ubuntu Linux, okay? Like this. Let's get rid of this for clarity. Okay, right. Now, basically, when a workflow is triggered, what's going to happen is when every time we make a commit to our repository, GitHub Actions is going to run what's called a runner, which is a way of thinking about it is like a kind of a freshly installed instance of a machine, in this case, running Ubuntu. And it's going to run the steps we're going to define in a moment. So instead of running them on our local machine, this is actually going to run them within the cloud, within GitHub's infrastructure, okay? And now what we do is we specify the steps we need to run. Right, okay, so now we need to specify those steps individually, and we do that by saying the steps, and then what we do is we specify the first step, which is we're going to check out our repository. Okay, now you'll notice here we're using a hyphen. This is another way of basically of stipulating a list of things that we wish to put into this definition. And we're going to use a GitHub action called checkout. And the version of that action we're going to use is version 4. Okay, right. Okay. So basically what's going to happen is the first thing this workflow is going to do is it's basically going to check out this repository, okay? Now, the next thing we need to define is setting up Python, okay? And what we do there is we say we're going to use another GitHub action, and an action is something that GitHub Actions is something you can select. It's like a function in a way that will do something for us. And in this case, there's a function which enables us to set up Python. And each of these different actions has different versions. In this case, we're going to use version 5 of this particular action, okay? And then we need to pass it an argument, which is with the version of Python, which is 3.12, okay? So this is going to set up Python for us so that we can effectively use Python, okay? All right, so the name entries we're putting here can actually read anything we like. It doesn't matter what we say there. This is just a way for us when we're checking the log of what's run, what's actually occurred. And the next thing we need to do is to install the Python dependencies. All right, and as part of that, we run a sequence of commands, right? And so under run, what we do is we specify Python 3 minus pip install. Now, exactly as we did on our own machine, installing these requirements.txt from our which contains our packages into a Python environment. Okay, in this case, it's just going to be on the machine. Okay, so all of those requirements that we've already stipulated end up going in there, and will be loaded in. So we load our Python dependencies. And then what we do is we run PyTest. I can spell PyTest correctly, which I can't. Right, okay, so, and run. So you'll notice I'm using a bar here. This basically is something that enables us to add any number of commands that we wish. So these are the commands that are going to run within this workflow, okay? So I could add another one here if I wanted to, because I've got this bar, which means it's a multi-line command. As it turns out, it's only just one command. But it's good practice just to use it just in case you do need to add any other lines. And then, as before, we're going to run PyTest with coverage, okay? And that's it. This is what we have. Right, okay, so that was a lot of typing. So I'm cautious of time. But if you've been able to get to that point, you give us a green tick. I suspect not many will have done so, maybe one or two. But at least even if you're not able to get to this point, I can at least demonstrate this for you. Okay, but I'll give you an extra minute. Right, so some of you have been able to do that. That's good. Okay, right, so what I'm going to do is I'm now going to run a terminal. Okay, and then what we're going to do is we're going to add this particular file. Oops, git status. You should see the .github directory appearing there. Okay, so what we'll do is we'll add the GitHub directory to version control and then commit the contents of that directory with our continuous integration workflow with first try at CI. Okay, something like that, and then do git push. Okay. All right, so if you've been able to get to that point, I'll just wait a second for you to do that. Feel free to let me know. So, okay, so added that to GitHub, first try at CI. And very quickly, I can see from time. Right, what I'm going to do now is, whilst you're typing that, I'm going to go to my Spacewalks repository, which is sitting on my GitHub accounts. Okay, and you will see, hopefully, you should see if you go there to your own one, you should see a little pending icon there, right? And that means that the workflow is now running. Okay, so we've basically uploaded this workflow to our GitHub repository, and hopefully, fingers crossed, you should see this pending here. Okay, so if you've got to that point and you can see a pending just here, give us a green tick. I'm not sure many will be able to say they have, but let's see if you have got one. Okay. If you're running into any issues, feel free to put them into the chat. I'm happy to stay around after as well and fix this if anyone's run into any issues with this. So if you have time, feel free to hang around. Okay, so a few of you have managed to get to that point. Okay, so then what we can do is we can just basically wait for this to complete. And let's see. So if we click on it, we actually get some idea of what's going on. And you'll see here that this has actually passed. Okay, so this continuous integration workflow has successfully gone through and hopefully run all our tests successfully. It appears that it has. So yeah, so if I now refresh this, you should see you get a green tick like this. Okay. If you click on that and then click on details next to this build and test, which is what you may remember we called our workflow, you will see it comes up with a detailed list of all the steps it went through. And you may remember we named some of these. We named set up Pythons, install Python dependencies, test with PyTest. And if we click on test with PyTest, you will see that it's run PyTest for us and run our tests, but it's also run the coverage as well and given us an idea of the code coverage for our tests as well. Now, this is going to happen every single time that we make a change to our code. So we get this for free now from every single point onwards that we make changes to our repository, which is really handy because it means that we don't have to run them. We should run them manually as well, but it means as anyone is making changes to this code, including ourselves, that this code is basically going to be checked for correctness by running these unit tests every time. And therefore, every time this is made, we can go back and check these results by going to actions here, right, in our repository. And you can see we'll have a list of all the different workflow runs indicating, and we can have a look to see if anything has failed or it's been successful. And if it's failed, we can have a look and see what the problem is and then try and fix it. So every single time changes are made, this is something that will happen basically for free. Okay. Right. So we managed to get to 1 o'clock. and I'm aware that went by incredibly quickly. So I do apologize for that, but I do hope it was useful.